Good evening, Shreyas sir. Good evening, Shreyas sir. I'm audible?
Hello.
Now you are audible. Yeah.
Okay.
Okay.
Shall we start, sir, or do we have to wait for?
Just a minute. We will wait for 2-3 minutes
Yeah.
so that all the participants are there. Will you please try to share your screen so that we can check whether the sharing is possible for you? Please unmute yourself. Okay.
Is my screen visible, sir, now?
Uh,
No?
no, it is not shared.
Sharing options.
At the bottom, there is again one button is there share.
Chrome tab. Let me just check. Sir. I hope it's visible now, sir.
Yeah, it's visible. Yes.
Yeah.
So you just need to make it full screen.
Sorry?
Just you need to make it full screen one.
Yeah.
Okay, it's great. It's visible.
Yeah.
So in next 2-3 minutes we will start in the day.
Sure.
We'll wait for this one.
Sure, sir. I'll stop sharing for some time.
Okay. Thank you. So I welcome all the participants for the yeah. So good evening all. So I welcome all the participants for this day four, two sessions. We have a very young and dynamic personalities today. One is the Dr. Srihasha Pandenya, who is from the Samsung Research Institute, Bangalore. Also, we have Dr. Vivek Patnaparthi, who is also from the Tejas Networks from the Bangalore. Both are working in the R&D. I hope they are going to help you out how the uh, technical cutting edge technologies are going to help in the farming. So we'll start with the first session. Our today's first session uh, is on low-cost client-server architecture for mobile-based seed quality detection. And we have today's expert is Dr. Sriharsha from Denmark. He is presently working as senior chief engineer at Samsung Research Institute at Bangalore. I just want to introduce him. Sriharsha Kombina is a researcher and learner with a PhD in machine learning and optimization. He has worked on a variety of projects, including developing novel methods for homotopy optimization based NMF, then training neural networks for simultaneous enhancement, and using genetic algorithms for regression. He has also worked on project devising novel frameworks for multi-camera AI-based automated surveillances. Kondane has also worked on a number of projects outside of his PhD, including creating web application to detect the quality of seeds, generating depth images and video using GAN frameworks, and working on a project from a well-known company which requires improvement in performance of OCR over old documents. Kondane has a strong interest in reinforcement learning, online learning, and Docker DevOps. He is also a skilled programmer with experience in Python, C++, and MATLAB. In his current role as chief engineer at Samsung Research, Kondanya developed AI-based image signal processing pipeline. He has also developed sort of deep learning models for mobile devices and research image restoration tasks and sort of deep learning generating models. Prior to that, he was a scientist at Mislava Systems Private Limited, where he designed and developed architecture for digital twin simulation for training purposes. He also developed machine learning algorithms for wide data sources and creating pipeline for unstructured and structured data sources. Has a vast experience in AI and machine learning, also developing a different application for various applications of with the AI and machine learning. I hope that the session uh, of this today's expert is going to help all the participants. I request Mr. Dr. Sriharsha to start with this session. Sir, please.
Thank you, sir, for that introduction. I hope I am audible.
Yes, you are clear.
Yeah. Uh, yeah. So let me also introduce myself, sir. Just so I have done my PhD from CSIR. So I have been working on multiple technologies, both client. I mean, the presentation is about client server technologies. So, but mostly my PhD, in my PhD, I have worked on machine learning algorithms and optimization algorithms. So my focus will be more on how to design a model for these kinds of applications where you can detect quality of seed, or you can so I will also show some of the code on how to train the models, how to train AI models, how to prepare data set, and what kind of data set can you make from it. So my lecture, or this FTP will be my a lecture in this FTP will be focusing on that aspect, although I will brush on client server architecture. So if you have any doubt on how to create a client server architecture, or how to make these kinds of applications, you can always contact me directly. Because of time constraint and the way we are structuring, so I am focusing more on how to develop AI models for these architectures. So I'll start, sir, with the lecture with your kind permission. Yeah. So let me just share my presentation. So I hope the screen is visible.
Yes, your screen is visible.
Yes. So basically, as I said, so it is mostly about seed. So the project is about seed quality detection. This project I have done during my PhD. So the idea is that if you are able to detect quality of seeds, or for that matter, any kind of any food item, so you'll be able to either increase the yield, or you will be able to help the farmers in a more technological way. So that was the idea behind creating this system. So this will help in many aspects. For example, crop health monitoring. Whenever you have the yield, you can detect what kind of pests are there. You can detect diseases. You can detect how the soil is actually retaining moisture or retaining the micronutrients and these kinds of things. As every aspect of the soil and the weather will affect the seed quality. So this kind of image based monitoring will help in assisting farmers basically. So definitely, if we are able to predict how the future crops will be, or how the future of these seeds will be, then we will be able to maximize the yield. So similarly, again, so this can also be done both ways. So either you can give it to a customer who is eating the product, or you can give it to a farmer who is actually making the product. So both these so for both the entities, this kind of architecture or this kind of application will be very helpful. So the objective of this workshop right now is to first of all understand the flow of how this application will be, how the server and client architecture will be, and then I will show small demo or small code based interaction where you can actually ask questions. So you can, I mean, I might not be able to see the screen, but you can just raise your hand and maybe ask the question in a question from the Zoom itself. You can interrupt me, no issues. Yeah. So I will be mostly explaining on how the AI solution will work on the seed quality detection. So the participants will basically learn on how to create the model, how to make a data set for this model, how to infer the results. So if you have any doubts, you can just ask me in between. So there are many aspects where we can on how to detect the quality of seed. So one is color, shape, texture, and size. So all these factors can be seen from an image that we all know anyways. So all these aspects will be used to detect the quality of the seed. So this application, this AI model, the image seed quality detection model, will actually look at all these aspects. In the practical experiment, I will show you how to design a CNN model on detecting on detecting or quantifying the quality of these seeds. So this will be again automated, because I'll show you the client server architecture. Before going into that, so if anybody is maybe guiding a project, or maybe you want to make kind of some kind of image detection software, so I want to emphasize more on the importance of dataset quality. So the more that you have, or the variety of dataset that you have, the variety of seed qualities that you have, then you will be able to create a robust application where you can infer, where you know the the quality of your detection will be much higher. So most people think that just by designing a network, I'll be able to, just by designing a AI network or just by designing a CNN based network, you'll be able to give the best software to the user or to the farmer. But that is usually not the case. Most of the inference quality or the software quality will be dependent on data set. So the way you make data set, the big the data set, the diverse the data set, the better will be your results. So that is what I want to emphasize more on. So that's why, so in order to create the data set, how do you create data set? So one thing is, since we are trying to make, or I am trying to present a low cost solution. So we have to make the data set as diverse as possible, and it should be based mostly on image, so that every person using a smartphone will be able to detect the quality of seed and will be able to use this software. So for that, how do you need to make the data set? You have to collect as many images as possible in as many lighting conditions as possible. So the lighting condition will make a large impact on the data set. I know, so many of these. So if you make the data set in lab controlled environments, then you will not be able to create a good software or good detection algorithm. So the data set, so the light when you are making any image based softwares, the lighting conditions are very, very, very important. So then you have to have a diverse kind of data set. So you need to have a good seed, you need to have a damaged seed, you need to have discolored seed, you need to have a non seed also, for that matter, some outlier. So you need to predict the outliers also. So again, all the preposing needs to be done on the image, so that you will be able to so the input to the models and input to the CNN models will be of similar type. At inference means whenever the actual user or the farmer is clicking an image and then sending it to the server for a quality detection. So there are some methods on how to prepare a better data set, and how to enhance the data set, on how to augment the data set. There are many kinds of transformations that you can do. That also I'll show you on how to do the transformations. And you can actually use a pre-trained algorithms also, pre-trained models, for example VGG based models for classification. Or and you can take that model, and then you can train the or retrain the model or fine tune the model for your application. So I'll just stop here, so that if anyone has any doubts, you can ask in between.
Sir, I have one doubt. If
Yeah.
we take pre-trained model, I mean, if we want to compare in research article, so in
Yeah.
case of pre-trained model, we won't be able to find the number of trainable parameters, right? In that case, we will have to train the model, no?
Yeah. So usually what you do in pre-trained model is, for example, you take a VGG 16 model, you chop off the classification layers, the last layers, and you keep part of the model. Okay, so that you will get features from that model. So from that features, you actually train your own classifier at the end. Okay, your own classifier at the end. So the parameters or you can actually freeze the model or you can retrain the model. Usually you freeze the model because the features that you get from a pre-trained model are trained on much diverse data set. So that's why you keep the features from the first part of the model or the larger part of the model where you get the features. So you'll have parameters, you can always have the parameters, you can calculate the parameters. There are ways to calculate the parameters of these models also.
Okay, sir. Thank you.
Yeah. Any other doubts? Please ask. If I know I might be jumping right into the product or the software, so that's why I stopped in between, so that you can ask doubts and maybe clarify, so that you'll not be you know lost in between. So I'll continue then. Yeah. So there are many ways to augment the data set also. You can do random kinds of transformation. For example, if you have a seed data set, you can actually rotate it, you can flip it, you can have different. So because the farmer will be actually clicking the image as he likes. So either you have to control the camera so that he actually zooms in on the seed, and you have to say him ki, okay, turn this way, turn that way, or you can take the image, apply all the processing in the backend at your server, so that you will get exactly what you need from the image itself. So there are many techniques. For example, you can super resolve to improve the quality, you can denoise to improve the quality of the image that you are getting, because the mobiles that farmers might have might be different from what you are testing. So all those things will be there. So dataset preparation, dataset augmentation, and dataset collection. So this is the main. It takes it. So it is 80% of your work. 80% of your work for a successful product. So so I may not be even emphasizing enough on the dataset. So that is the kind of importance that dataset has. Now, so we can start with client server architecture. So what do you mean by client server? Basically, the user, that is the farmer, is your client, in the sense the mobile in farmer's hand is your client, technically speaking. And you will make a client based application for that mobile, right? So it can be an app, it can be from browser, it can be directly from, for example, you have an image and you can upload it to database from the PC. So you can choose how to create a client. So let us suppose I am creating an app where you can actually click an image, uh, where you can actually click an image, the user application, you can click an image, and the application will upload the seed image to the server, or the server is basically our seed quality classification API. You can create, so what I am saying is you can create an API is basically even any client, even if you are not creating the client, they can also hit the API, and they can take the decisions that you make, that classification decisions that you make, and they can even show it in your show it in their interface. So for example, you have some government website who is actually sending you like 10,000 images of seeds at a time. So that can also use your API, or a single farmer clicking pick of single seed and then hitting your API. So your API must be as scalable as possible, and as scalable as possible, and it should be able to classify as diverse kind of requests coming from different clients. So that's why you have to have a server client architecture, where server should be independent of your client. So the server should work without having a client. So they should not be interlinked without they should not be interlinked without any separation. So now, as soon as you get image, what do? You actually pre-process the image. What do you mean by pre-processing the image? You can denoise the image, you can rotate the image, you can super resolve means getting into a higher resolution. Super resolve the image. You can actually change the format of the image. For example, most probably you might be getting the image in RGB, but if you want to use color information, you can convert it to YUV formats. These are basically image formats. So you can convert it to YUV format, you can convert it to HSV format, or even gray format, if you are going to classify using texture or size or something like that, right? So I'll stop here again for your questions, if anybody has any questions. Any questions here? No? Okay. Uh, yeah. So this is the kind of architecture that you will usually design for server client applications, where you will have a classification model, which is mostly AI model, because you should be able to cater to different kinds of diversity from the images, and then you post process in the sense, if you are giving a certain kind of report, then maybe you will have to do some kind of post processing on how you are getting the result itself. So those kinds of things you have to cater for in the server. So if, for example, if a government organization is hitting your API with lots of images, then you should be able to make a report from the server, so that from this location, or these kinds of seeds are faulty, or has some kind of disease, or doesn't have good enough yield. So those kinds of reports also should be able to the server should be able to generate. So that all those processing will happen in the server. So now basically I will jump on to the coding part, where you can design a classification model, so that you can actually, I will also share the code if there is any model for it. So I'll also share the code. I'll just let me change the tab sharing. Yeah. So are you able to see the screen? Anybody can answer, by the way.
Yes, please.
Yeah.
Yes, yes.
Yeah. Thanks. Yeah. So basically, what I'm trying to do is I've taken a open source data set for soybean seeds, where you have different kinds of varieties of soybean seeds. So first you have to I'm just importing the data set and importing some of the libraries in Python. Okay. So I have already run this. Yeah, run this application, run this notebook, anyways. So these are the kinds of seeds that you can get. Okay. So immature soybean. So basically, they are categorizing them by different kinds of sections that they want to classify. For example, if there is any disease, so it might be something like this. So, and if it is a good soybean, it can be something like this. If it is a broken soybean, it can be something damaged soybean and broken soybean. So these kinds of things can be useful in many ways, for farmer, sure, for food processing industry, yes, for government websites, yes. So if you want to make a good quality soybean, let's say any extract that you are getting from soybean, so those kinds of things they can directly verify. So you can keep a camera in their industrial pipeline, and then you can actually sort them out, or at least test the quality of those seeds. So these kinds of things you can take. So in this data set there are 5 classes: immature soybean class, spotted soybeans, intact soybeans. So if you see here, so if I take an image of so if a user has to take image of soybean in this kind of format, so usually he will not be able to do it, because either he keeps his mobile a lot distant from the soybean, or the lighting condition will not be similar to this, it will not be as bright as you need it to be. So there will be some if shadow is there in this part of the image, then you will not be able to see the immaturity in the soybean itself. So in those kinds of condition, you will need a lot of pre-processing to be done mostly. Yeah. Yeah, please. Someone is asking a question, I guess. Just a sec. No question. Okay. Yeah. So in those kinds of situations, you will need these pre-processing steps, where you will actually have to illuminate the image in these shadow regions, and you have to get the image to be brighter in those part, and then send it to a classification model. Otherwise, the model will not be able to recognize, and it will be saying that it is a good soybean, or it is a broken soybean, or it will classify it bad. So those kinds of mistakes will happen. So yeah. And there might be other things also. So as I said, he will be taking the image from far away place, so he'll have to actually recognize the object. So there might be an object detection and object detection and cropping step in between. So this also will come under pre-processing step. So for that object detection, either you can use some kind of computer vision based methods or AI based methods, which are much more prominent now. You can use pre-trained models there also. So with that object detection, you have to crop the image for your desired size and then send it to the classification model, right? I'll stop here for any doubts.
Sir, I have a simple question. What impact it has if a data set is not balanced? Like you have written in the slide now, in pre-processing step is also to make the data set balanced. So what impact it will
Yes,
have
yes.
on the results?
Yeah. So basically the only impact that we'll have in classification model is that it will not classify right. Okay. So that is the main impact. So for example, if it is not balanced, in the sense I have a lot of spotted soybeans and very less intact soybeans. Okay. So then even if I get an intact soybean, since the dataset is not balanced, in the sense there are a lot of images in spotted soybeans, so it will actually classify even an intact soybean as a spotted soybean, which will be obviously wrong, and which will affect the decision making further on. So that is one kind of balancing in the sense of classes. The other kind of balancing that you have to do is, again, lighting conditions, noise, different kinds of images, different kinds of zoom levels, different kinds of angles. Okay, so these kinds of balance should also be there. Why? Because for example, all my data set is taken with good lab conditions, where you have good amount of light and you are able to see the bean very well. But let's say the farmer is actually taking the pick at night. Okay, you don't have light at all there. So then the model will not be able to classify at all. Definitely it will give some answer, and definitely it will be wrong. So that kind of balance should also be there. So if you are making an image based data set, it is not just important to have all the classes. It is also important. So when I mean balance, it is also important to think in terms of image processing also, because ultimately the model, although the application is agriculture based, so you should have classes. Ultimately the model will look at it as an image, so it will have all the problems that any image processing module will have. So what problems will an image processing module will have? Lighting, zoom, noise, so all these problems. So the data set must be balanced in every aspect of the actual entity, that is the image processing form, and the application entity, in the sense of classes of your seeds or anything else for that matter. Yeah.
Thank you.
Yeah. Any other doubts? Can No? Okay. So these are the kinds of beans that we have. So I'll be training a small model here. Okay, I'll just start the sorry. I'll just so I'll explain in between what I am doing. Meanwhile, the model will be running. Right. So the model is running now, basically. So what I have done as of now in terms of code. Okay. So first of all, I have taken the data set. Okay. Soybean data set, and I have given the size of the image, that is 64 by 64, and I have loaded it into my image data generator. Okay. So this is basically, I am using TensorFlow, by the way. If so, I will share the code in through proper means anyways. So basically what I'm saying here is the dataset is categorical dataset. That means my dataset have different kinds of categories or classes. So actually the image data generator will knows how to categorize. So it already has the inbuilt functions where if you keep the data set something similar to this, okay, in folders. So in folders there will be images here, okay. So in each folder there will be images like this .bmp images as of now. So in each folder it will be images. So what it will do is it will take all the images and assign the specific class to it. So in all the images in this folder will be in broken soybean. All the images in this folder will be in immature soybean. All the images in this folder will be intact soybean. So similar to this. Sorry. Hello. Is there any doubt or should I continue?
Please continue.
Yeah. So so the categories will be again defined by the folders itself. So in all these folders you will have the images, and you can actually load all the data set using image data generator in TensorFlow. So after that, what I have done is I have written a simple model where I am using two conv layers. Basically conv is basically where you are extracting features. So these are basically features. In at this point you will get image features. What these features will actually learn is how is the texture of the input, how is the what is the size of the input, is there any different kind of texture, if there are any specific feature that it needs to extract from these classes, it will extract in these 64 features. So I have kept it as 64. In these 64 features it will actually have some kind of thing which the next layers will be able to separate each other from. So for example, if I have this, okay, anyways I have generated it. So if I have this kind of pattern here, okay, so this kind of pattern here, so this will be appearing in one of those. So in one of those 64 features, in one of those 64 features, at this point there will be some kind of blob saying that it has some kind of spot at that location. So these 64 features will be actually separating it out, or it will be taking it into higher dimensions. I think most of you will know PCA and ICA. So these features will be actually taking the image into higher dimensions where you will be able to separate them out. So those separation will be done by using conv2D and these 4 layers. Okay. So after this, I am flattening it out so that I will be able to separate the features into different kinds of classes. Here I have 5 classes, right? So that's why my output number will also be 5. The output dense will also be 5. Train.generate number of classes, which will be 5. So I'll stop here again for any doubts.
So 64 is features or it is number of neurons? I mean, is it same?
So basically 64 will be number of kernels. So what the layer here signifies is for each conv2D there will be 32 kernels. Okay, so 32 kernels, and if you are giving an RGB image, so with the you will have 3 channels in RGB image, right? R, G and B. So from that it will first extract 32 features. So 32 features are, you are getting those 32 features from 32 kernels, 32 con kernels, which are nothing but neurons. In if you are using a dense layer, it will be neurons. If you are using conv layer, it is basically named as kernels. So you will have 32 kernels. Correspondingly, you will get 32 features. Yeah.
Apart from using the softmax layer, can we have sigmoid to get the?
There are 2 things here. Why I am using softmax is basically what softmax does is it gives me a combined probability. Okay, so since I have 5 classes, I will know the maximum of them, maximum probability of getting one class. Okay, so if I use sigmoid, it will be independent. So you can get, for example, 50% for one class and again 50% for other class also. So those kinds of things can happen when you use sigmoid. That's why we usually, when we are using classification, so you are separating it out into classes. That's why we usually do softmax. So although the number will be similar to sigmoid, but softmax will actually look into other classes and give you probability of the best matched class. Although you definitely you'll get from others also, but yeah. So that is the reason why we usually use softmax for classification.
But with the case of sigmoid, can I able to find out the likelihood probability with respect to
Yeah.
100% for the R for the R
Definitely,
classes?
definitely. But you will have to design a post processing layer with sigmoid also, where you get the probability. So you have to design it your ways. Whereas this, it will give me directly.
But I wish to know whether the same feature class is present into another class. So in that case, I can able to find out by using sigmoid too.
Yes, that's what I'm saying. So even by using sigmoid, you will be able to get the classes, no doubt. Okay, you'll have 5 outputs with sigmoid, and you'll know the percentage of similarity of the input image with your classes, and most probably you will take the maximum similarity, right? So that logic you will have to write it after you get the output, right? So if
But
yeah.
I'm sorry to interrupt you. I want to
No, no,
get the likelihood probability from the different classes.
yeah.
So there
So
might
that,
be a feature mismatch between the one class to another class. So how
yes.
can I able to achieve that one?
So that's so feature mismatch in the sense. What do you mean by feature mismatch?
The broken and the immature.
Yeah. Okay,
There might be a seed which that seed contains broken also and immature too.
immature also. Okay, okay.
And
In
I want to
those
find
kinds
out
of,
both the features in the same image. How much
yeah.
percentage is it?
So then maybe you will go with sigmoid, and maybe you look at 2 of the most probable classes. It can give you both broken, and it can give you immature also. But the probability or the value that you will get, let's say I'm taking it as probability. I'm just for conversation purpose. So
So
for broken, it can be 50.50, or and for your immature it can be 0.40. So
where
then
can I
you will
able to
be,
find out that ratio?
where will you able to find out the,
That ratio 50%, 50%.
so if you use sigmoid, you will get it while you are training. You can use sigmoid. So that's what. So if you use a data set where you have multiple classes, what you are saying is basically, if I have multiple classes in the same seed, that's what you are saying, right? So broken and immature on the same seed, then how can I classify it, right? So then so you have to first of all include it in the data set for the network to learn it. So the data set must contain samples, and good enough samples where you have both broken and immature. And then you can actually use sigmoid function, where you get since we have 5 classes, where you get 5 outputs. And so 5 outputs, and each output will give you the probability of that specific class itself. Okay. So for example, if it has both broken and immature, it will give you maybe 90% for both. Okay, 90 and 90 for immature, and all the others it will give you maybe 8, 10, and something like that. Right, for lower probability. So in that case, if you have multiple classes, you will have to use sigmoid, and then you can write logic according to your wish. So if you want to say that it has both the classes, then you can look at the sigmoid values. You can write a logic afterwards. Yeah, I hope I answered your question.
So one more question I have in the transfer learning models, we have generally 224 by 224 image size. So here you've taken 64 by 64. So can you
Yeah.
just clarify what is a good size when we build our own CNN, and also the reason for this 32, 64, and 128 kernels?
Okay. So first, the first question is basically regarding the size of the input, right? So that size is basically from the data set itself. So since the seed is very small, okay, and the image can be very big, so when you cut it, you will be getting smaller patches. So if I have to include only seed in the image and not all the background data, in the image, I'll have to cut it to the most optimized size, so that my background information will not affect my classification. So that is how we have to do it. Now, the client, or where the farmer or the government or anyone else who is actually pinging the server with different kinds of images, will not be able to ensure that, right? So that's why either you have to include it in client side, where he has to zoom to that 64 by 64 level, so that the image contains only seed, or you allow the or the client to take any image that he got, you get it to the server and then pre-process it. What will the pre-processing steps be? So you have to first of all identify where the seed is, and then crop the image. All this must be done automatically. So identify in the sense not manually, but by using some kind of object detection method. So you have to identify the seed, crop it manually, and then resize it. Resizing it means even after cropping, you can get, let's say, as you were saying, 256 by 256 patches. So you have to resize it to 64 by 64, because your model was trained in 64 by 64. So those kinds of pre-processing steps are necessary when you are making a a customer based application. So all these, actually these kinds of things we go through when we are making the pipeline also. Yeah. So that is question number 1. Have I answered your first question, or do you have any
Yes,
doubt?
yes, sir. Sir, does it also have impact on training time if I reduce the image
Yes, yes.
size? Okay.
Yes, it will have impact on your training time. It will have impact on your inference time also. So whenever you get new image, you will the size of image will impact your inference time. For example, if you have 10,000 images, let's say, rather than one image, and they are pinging your server constantly. So if you have 10,000 image at a time, and your model itself is taking, let's say, 2 seconds or 3 seconds for an image, you understand the latency that the user has to go through, right? So they will have to go through like maybe 10 or 15 minutes to get a simple report, where maybe an expert can just see and say. So those that kind of latency will affect. So that's why the smaller the image size, the faster the model will be. And of course, you can have hardware improvements at your server side, so that more number of GPUs, or maybe parallelization. So all those are again different aspect on how to design the server itself. So but yeah, you will have latency at your latency if you increase the size of image. Yeah. So that is your first question.
Yes,
Second
sir.
question. Yeah. So I think that first question is right. Okay, you understood the answer, right? Yeah.
Yes, sir.
So the second question, why did I take 3264? First of all, I have 64 by 64 images. I only have 5 classes. Okay. So there is usually what happens is, if you take any GPU architecture, okay, or NPU architectures, where this acceleration of the models, of deep learning models happen. So there, uh, much of the acceleration will be dependent on how many layers and how many kernels that you have. Okay, so that's why we usually take this number to be in the power of 2, or or sometimes it will be like multiple of 16, multiple of 8, depending on your GPU and GPU architecture. So why we take power of 2? Because it will be able to parallelize its operations much in a much optimized way if it is in the power of 2. Okay. So but it doesn't mean that logically or algorithmically it will not classify the image if it is, let's say, 33 or 34 or anything like that. That is point number 1, why in the power of 2. Point number 2, why you need 32 features, whether you can go to 16 or you can go to 64, I mean in the first layer itself. So usually what happens is, if you are going step by step by increasing the number of features, the learning capability of a convolution network will be much more. Okay. So so it actually goes step by step, and it will not be, so you can actually go from here we have 3 channels, 3 to 32 or 3 to 64 directly. It will also be good, but most of the features will be sparse. So they will be zeros, and you need not need them. So you can increase, but if you decrease, then it might impact your classification capability. That is one. So second, while going in a convolution, so this is proven empirically, in the sense in papers also you can see this. So if you increase the number of features steadily, then you will be able to get better, or what do you call it, hidden kind of features from the image, right? So from 32 to 64, then 64 are hidden features, right? So latent features of this 64, this second layer will be of different abstract level, right? In 32, what the features can be something like this. So it has color so and so, it has it has some kind of what do you call it, has brightness so and so, it has shape so and so. So those kinds of low level features you will get in the first layer. In the second layer you will get a little bit higher features. For example, the texture of this part will be like this, the texture of the next part will be something, or texture of the, the, what do you call it, the spotted beans, the spot will be something different, texture of this damaged will be something different. All those features will be extracted in latent layers. So in the first, usually in the first layer, second layer, you will not get those latent features. That's why you need 2 and 3. Rather than taking 64 in the first itself, you have, if you go step by step, then you will get better latent features, better texture features, better edge features, which are very useful for classification in the next layer. So think of it like an expert actually making it out from the. So if you ask an expert how is this seed, how will he think? First he will look at color, first he will look at size, and then he will look at texture. So in the similar manner, we will go into different kinds of layers and different kinds of features. Yeah. So that is the reason why we have 32 and 64. I hope I answered your question in this second question. Hello, am I audible?
Yes, it's something. In chat box, she said yes.
Yeah. Okay. Right. So that is how basically we have designed this conv network. If, for example, if you have any other doubts, please ask now on this network. Okay. So then what we have done is we have compiled the model and we have said that use this kind of loss, categorical cross entropy. Since we are using classification model, we have used this categorical cross entropy. And usually, I mean, this is one of the advanced optimizer, which is Adam optimizer. So we have used this optimizer to compile this model as of now. So then what we have done is we have trained the model here for just 10 epochs here. So nothing, not for a lot of time, just for 10 epochs. Let's see how. So by using this fit method, we have actually trained. Let's see how this model is performing now. So just randomly, I'll pick the images out. Okay. And I'll just show you what the solution is. One sec. Parent folders. Just a sec. content soybean underscore data.
The folder name is something different. I think.
Okay,
Content, yeah.
content is there. Yeah. Yeah. So let's see how this model is. So I have only trained for 10 epochs, right? So the actual of this is broken soybeans. Since I mean the data set is again limited, so it has predicted actually to be skin damage soybean, the model itself. So but immature soybean, yeah, it has predicted it right. Spotted again because this see, so this is not very evident. See, if you see actual what do you call image skin damage soybean here. Okay, skin damaged. This is skin damaged soybean, and this is immature, and this is broken soybean, right? So although that was a broken soybean, it actually so since the classes are not very far apart, so the model got confused and then said, okay, so this is a skin damaged soybean rather than a broken soybean. So that is okay, acceptable for to some extent, but still it has to be classifying much better. Yeah, so immature soybean, it has classified it better because I mean the texture itself. So it has actually looked at the texture, and since it is much much closer to or much firmer, so it has actually predicted it right. So since the spotted soybean has a very distinct classification feature, so that feature has enabled this model to predict it right. So yeah, so these are the predictions that you can get from these kinds of models. So it has maybe around, what do you say, so in 6 images it has predicted 4 right. So that is a good accuracy for now. So so this is how basically you will classify or you create a AI model to predict seed quality, or for that matter any kind of quality in especially in agricultural context. You can take, let's say, a leaf, you can take a stem, you can take soil, you can take seeds. So all these kinds of things you can actually take an image of, and then create a good enough data set, train a AI model for classification, and then maybe send the results to the user, so with all the pre-processing. So if you have any doubts here, I think I'll close my lecture here. So if you have any doubts, you can ask. If you want any discussion, you can ask. Yeah. Hello. Hello.
Yeah, please continue.
Yeah, so I have so I will conclude my lecture here basically on how to design AI model for this classification. So if you have any doubts, and if you have any doubts on how to create a server client architecture on your user application, you can directly contact me. Yeah. So
Yeah, there are some of the questions in chat box itself.
in chat box. Okay, okay. Yeah, let me
Can
just.
you comment on this side for
Sorry?
different state of Indian origin?
Sorry, I am not able to get your question.
Where can I find the data set, a large data set for all the types of seeds in Indian origin?
All the types of seeds. So basically, this data set I got it from Kaggle. So usually Kaggle hosts a lot of data sets, but for Indian origin, I think maybe CSIR or Indian Agricultural Research Institute, those might be having the data set, but you have to contact them. So but they might not be as curated as you want it to be. So it is, so if you want to make an application, it is better to invest in making the data set. As I said, making the data set is what makes the application successful, or the inference quality better. So you have to invest in making the data set yourself as per your need. So that is better. Most probably CSIR might have some of the data sets. Yeah, I know some lab in, I think in Madhya Pradesh itself, where they have this soybean data set itself, Indian soybean data set. But I specifically don't know where you can get it from. So I'll look at the other questions. What should the number of samples taken to train with deep learning techniques? So the more the better, the number of samples. So as many samples that you have, the accuracy will be that better. But even more important than number of samples, the diversity of samples is much more important. So you have to have all the variety, as I said, both in image processing perspective and application perspective. So if you want to have all the 5 classes, and if you want the inference model to work well, then you have to have balanced data set in terms of classes, balanced data set in terms of conditions, lighting conditions and everything. So the answer to your question is as many as possible, but most important is diverse as possible. Is it always we need to consider benchmark data set? No, it is, I mean, it depends on your application. So if you are making an application yourself, as I said, you have to invest in making the data set first, then only you will be able to make a better data set. Creating a data set takes a large amount of time, that is given. But if the application has to be successful, then you have to go through that process. But if it is for example, let's say some kind of engineering projects or something, you can get many hosted data sets in Kaggle, and there are, I mean, you can search it. Mostly I look it from, or take it from Kaggle itself, open data sets. So you can integrate this model into Android app, definitely. But as I said, if you integrate it into Android app, it will take a lot of resources from the mobile, right? And you have to perform a lot of pre-processing steps for the model to work. So even if you keep it in Android app, for you to make it work, it will take a lot of resources which the mobile or smartphone might not have. That's why it is better to create in a client server architecture way, where you are hosting a server and you are hosting all these kinds of AI models in the server itself, and the client, which is nothing but an Android app, will send you a picture, and the processing will take place in the server, and then you can send the results back to the server. So that will take better, I mean, that will be better usage of resources. He just needs to connect to maybe 4G, 5G or Wi-Fi, something like that. Yeah. If you create our own dataset, where can I host it to make it available for other researchers? So you can host it on your own website, for that matter. For that matter, you can host it on Kaggle also, but you can host it on your website and market. In Kaggle, you will have, I mean, you can host it on Kaggle. Yeah. I think those are the questions. Any other questions? You can either type in chat or you can ask me.
Yeah, I have given a right to unmute the participant. I request participants, if they have any questions, they can unmute themselves and they can ask you.
Is it always we need to consider? Okay. Yeah, you can. Yeah, you can get my mail ID. I think it is. I have given it already. Can we integrate this? Okay, if you create. Yeah, I have given my mail ID. You can contact through my mail ID. Where is it deployed and available? This is not deployed yet. So this has been done as a project while during my PhD. So about Euler model, what is the significance of training loss in evaluating a model? So in evaluating model, you will not have any significance of loss. So while evaluating a model, all you need is how the user, what is the accuracy of your classification? What is the accuracy of your, maybe if you are doing image denoising, what is the accuracy of the, how much of the noise you are able to remove? So those kinds of things. So evaluating the model you will not have, but while training the model, you will need a training loss. So the better loss that you take, better, again, it again depends on your data set. If your data set is faulty, whatever loss you use will not be useful. If your data set is good, then loss comes into picture. Usually in image processing tasks we use L1 loss, uh, L1 loss and SSIM loss in image processing tasks. In classification task we use again categorical cross entropy that I have shown you. Where can I ask it? What are other major parameters used in seed quality? So as I said, so the parameters or the features of the seed that can be used for these kinds of assessment, those are actually extracted by the convolution network itself. You don't need to extract it yourself. And we usually, as a human, we will not be able to quantify the feature that we are seeing
Dr. Shiharsha, you are not audible.
Hello.
Yeah, now you are audible.
Yeah. So yeah. So if you have a good enough data set and loss function, then the all the major parameters that are used for assessment will be extracted by the convolution network itself. So you need not do any analysis by yourself. You just need to categorize it well. For example, if you categorize a broken seed into a, let's say, spotted seed, then your network will not be able to extract the parameters well. So those kinds of problems you will face if you don't categorize it well. About YOLO model, I don't understand. What is, so number of samples taken to train thing is always, we need to consider data set. If we create our own data set, where should we? Okay, that also I have answered. May I know your research work? So basically, I am working mostly in camera pipeline. So in image denoising in Samsung flagship phones. So yeah, image denoising and image enhancement models. So other challenges. So mostly if we don't have, okay, so you might not face any challenges in this model, but if the pre-processing model is not able to give a better, for example, 64 by 64 cross image to this model, or better zoomed image to this model, or if it is, let's say, if it is changing some properties of the image itself, so then you will be facing problems with this model. So it will not, basically the problem, there is only one option to go wrong. It will not classify it right. That's it, right? So it can happen in any way. So if, for example, if you have trained it using an RGB, and the pre-processing is actually changing something in RGB, and maybe if it changes the ratios of R, G, and B. Okay, maybe if you use some kind of gamma on image, then its accuracy will be faulty. Yeah, someone is speaking there. About YOLO model, I did not understand the question. About YOLO model, what are other challenges? Okay, sometimes accuracy, precision, recall are same. Is it correct model? Precision, recall, accuracy and precision. So basically these are, these are ways to identify the quality of your model. Basically, you can use precision, you can use accuracy, whatever the word you want to, but what it means is how better it is able to classify. So usually what, when you are training, okay, maybe I have mentioned it in the slide. So usually when you are training, you have to divide your data set into three parts at least to test your model. One is training. Most of your data set will be in the training data set. It will be maybe around 60-70%. So some of the data set will be in validation set. The validation set should be completely disjoint from your training set, right? So why disjoint? Because when you are actually checking the validation, the model will also be checking the validation if you give validation data set to it. So so you can actually so each epoch will be different. Once the loss is minimized, once the loss is optimized, each epoch will be slightly different from the other. So you can actually choose one of the epochs. Epoch means, as I said, when it is training, it will go in rounds. So it will pass the data set through the model, it will calculate loss and then back propagate the loss. Most of you might know, I'm just explaining it just for convenience. So it will back propagate the loss through the model. So then the model gets updated with the new weights, right? So each of these weights, you can call it as an epoch. So for each epoch will be certain little bit different from the other epoch, because the loss will be varying, the data set will be random. So all these conditions will be varying. So if you want to choose between one epoch, for example, you have 1,000 epochs. If you want to say, if you want to choose one epoch, let's say from 900 to 1,000, you want to choose one of those 100, which is the best epoch. So you will have some kind of parameters to assess the epoch like that. So either you can use accuracy, you can use loss function for each epoch. Maybe you can actually take the outputs from each epoch and then test them, and then test the accuracy yourself. So these kinds of things you can do on picking the epoch. So that epoch you can use it for inference or commercialization. So so that is how you use accuracy basically. Is it good to work on image dataset or text dataset? That depends on, your choice. Text datasets and images. So text datasets, maybe you will have more data to collect because there is huge amount of web. Image datasets, maybe you have to collect by yourself. So if it is a project, if it is a student project, maybe I would prefer, if you have image dataset and you have a problem very specific and available, then you might go for image datasets. Otherwise, text dataset, maybe you can scrap from web, of course, with permissions and all. So how large dataset is required to get prior datasets? As I said, so the dataset, as large can it be, but the most important thing is diversity. Then, the size of the dataset. Any more doubts? You can type it in the chat, or you can ask me directly. That's it, I think. So, sir, I think we can conclude the session, sir.
Yeah.
Or, yeah.
So just let me ask, dear participants, do you have any questions? Let me ask, I have actually a few questions from the
Yes.
participants, those who are attending with me there.
Sure, sure.
We have a different types of seeds are there.
Seats, yeah.
Yeah, so just like in agriculture, we have lots of different shapes and types of seeds are there.
Yeah.
Whether the same type of model is going to work or we need to do so many modifications.
So if for example, if you have a larger data set, sir, and if you have a lot of diversity in the data set, you might need a bigger bigger model. So I have only kept, for example, 4 or 5 layers, right? Excluding max pool. So but if you have a larger data set and if you have larger diversity, you might need a bigger model. You might need, let's say, 10 layers, 12 layers. So depending on the data set, depending on the diversity of the data set, you'll have to increase the number of layers. So this simple model might not work if you have a bigger data set. For example, you want to classify between you have different kinds of seeds also. Here I have only shown you soybean seeds and inaccuracy or the problems in soybean seeds. If you have, let's say, different kinds of rice, wheat, and all those seeds, and you want a single model to be able to classify all of them or be able to work on all of them, then you will need a much bigger model actually. Yeah.
Okay. Yeah, there are other seeds like the flower seeds, which are
Yeah.
mostly the size is very small,
Yes.
even
Sir.
than the soybean,
Yeah.
and even they are just in one color.
Yes. Yes.
So
Yes.
in that case, how we can track the different?
So in that case, what we have to do is, first of all, sir, if it is a single color, so there must be some visual difference that we have to see for this model to work. So since this model is working on image-based analysis, so the defect first of all must be visible in the visible spectrum itself. It should not be in, let's say, infrared spectrum. It should not be in other spectrum. If it is in infrared spectrum, then we need to have infrared cameras or something like that. So that is point number one. So since the seed is very small, so there are two problems here. So you will not be able to zoom it well. So then what you have to do is you have to first of all recognize the background and foreground. Foreground is your seed, background is your anything else. So you have to separate foreground and background, separate the seed out, and maybe cut it into the exact dimensions that you want. That is, in this case, 64 by 64. If you have a different model, maybe if it is a smaller seed, you can take 32 by 32 also. So that if you want to make specific model for, let's say, sunflower seeds, so which is very small. So now you have to cut it into 32 by 32 image where only seed is present, and the defect must be visible. So it should not be, for example, the outer seed might look well. So it might be exactly similar to a very good seed, but the inner part of the seed might be hollow. So if you want to identify that, you will not be able to identify with this model. So you'll need, let's say, some kind of x-ray kind of thing where you will be able to see that there is nothing inside, it is not solid. So those kinds of things. So that is basically limitation of image based models. So the defects must be visible for the expert or to the model, both actually.
Okay. And now just this is what actually we have done, or whatever the code that you have shown, generally work on the laptops or computers.
Yeah.
Mostly we need, suppose we want to integrate such type of application on real-time systems.
Yes, sir.
How do you focus, or how do you describe?
As a, yes, sir. So that's so in the client server architecture slide that I have shown you. So the client, if you want, you want a real time system to be working on this kind of model, right?
Yes. Sure.
So if you so the client will be actually taking the photo, the farmer will be taking the picture. So then you basically what you will make is you will make a small Android app where you will take the image, so it will actually access the camera of the mobile of the smartphone. It will take the photo, it will send that photo to your server through some kind of network, either 4G, 5G, or Wi-Fi. So that image will be should be processed, pre-processed, and classified, and maybe a report must be made at the server level. So if you want to make a low cost and working model, then you will need this kind of architecture where an Android app, which basically has two options only. One is to take the photo and send it to the server. The second is to show the report. So as soon as you click the image, it should send it to the server where all the processing will take place. The report from the server should be displayed on the Android image. So this will be a good real time system for you to focus on if you want to make this kind of system. Yeah. This should be an architecture for your
Okay.
client server.
In most, whatever we have participants are there, most of them are from the academics background.
Yes, sir.
One of the participants asked how students can start to work on such type of projects.
It is better to take. First of all, there will be three parts here. One is making an Android app or client architecture. It can be browser based, it can be Android based, it can be anything else. You can have a specific hardware also. So the projects can be three ways here. One is to make, if it is for a BTech student, one is to make an Android app with those two functionalities that I have just said. So to take a picture and then send it to server. So that is one part of the project, maybe bigger project. One student can take. So the second part is how the server will pre-process the image. As I said, it has to do object detection. It has to crop the image. It has to clear out all the illumination defects, all the image processing based defects that you will get, noise and everything, or super resolve. So that can be one project where you can actually super resolve, you can detect object, you can cut it, and then you can provide a cut image as an output. That can be a second project. Third project is to train these kinds of models. That is, to train these kinds of models, you first need a data set. So making data set itself is a project, can be taken as a project, and it is being taken as projects in many academic institutions also, because making data set requires a lot of skill. So that itself can be a project. The that will be third project. And the fourth project will be to train the model and to make a report so that it can be sent to the Android client. So that can be a fourth project. So the whole system can be divided into four projects, and maybe students can work on each of the part. So that will be a better model for the students to work on.
Okay, so regarding the seeds, we have two scenarios are there. Mostly
Yes, sir.
either the seeds are used for the consumption purpose or maybe again used for the fertility purpose,
Huh.
again sowing. So
Yes, sir.
one of the participants asked the question that whether we are able to know the percentage of fertility of the
Yeah.
seeds from the sample of the seeds.
So I actually don't know whether the fertility, whether if an expert, let's say, if an expert can detect fertility just by looking at the seed, okay, then it is basically in visible spectrum. Then the image can also capture it. So if an expert can't do it, then we will need some kind of other sensor, let's say infrared sensor, or maybe X-ray. So those kinds of sensors, if it is in, let's say, a bulk mode, maybe some cooperative society or something like that can would be able to afford a simple X-ray machine, maybe low cost X-ray machine, where you can actually pass through this. And the same similar model, similar architecture will work on X-ray images also, will work on infrared images also. So you just need to make data set with that kind of modality. So infrared image or X-ray image or visible spectrum. If it is in the visible spectrum, it will be in phone. If it is not in the visible spectrum, then we will need to provide those kinds of sensors somewhere, I mean, to the farmer.
Other than the image processing, would you suggest other methods that can help the detect the seed quality?
uh, Other than image processing methods, so as I said, so again, X-ray and all those are also image processing methods. Maybe you can take the moisture of the seed, okay, or maybe if you can make a small sensor, maybe an electronic student can work on this project, where he will be able to get the composition of the seed just by picking it. So maybe make a micro needle where you can get the composition just by picking the seed, and that information can be sent to the server, where the server can that is again a data analysis part. It can be done by AI model, but you can actually analyze the data from the seed. Maybe it has so and so kinds of this percentage of moisture, this percentage of nitrogen, this percentage of phosphorus, something like that. So it will be kind of chemometrics kind of project. Yeah. So you can know the chemical composition of the seed by some analysis, maybe lab or microneedle if a student can work on it. So those kinds of things, yes, it's certainly
So we
possible.
will take the last question, which is in the chat box.
Yeah.
What
yeah.
is the bare minimum quality of image of the seed that we have to require for the detection?
So basically, bare minimum is where a human, if a human is able to recognize the the problem in seed just by looking at it, at that image. So that is basically bare minimum. That is basically a visual quantification of your bare minimum quality. So you can make a metric by analytic methods, but it is better to check with a human eye whether you are able to identify the issue or not, or an expert at least is able to identify the issue or not. If he is able to identify the issue, then that is okay. If it again, the resolution, if it decreases and the expert is not able to identify the issue, then it is not I mean, that kind of data set is bad. You will not be able to use it.
Okay.
Yeah.
So I hope actually we don't have any questions from the participants.
Sorry, sir.
So I think we don't have any questions from the
Okay.
participants.
Yes.
So,
Okay. Okay.
so thank you, Shreya.
Thank you, sir. Thank
So
you
this
very
is a
much.
wonderful, actually participative session today we have. Most of the participants, I think, clear their doubts regarding how the AI and machine learning can be implemented for the seed quality detection. And there are
Yeah.
many technical doubts also. People have, I think, cleared their doubts.
Yes, sir.
Yeah. So thank
Yeah.
you for accepting our invitation from the
Thank you very much,
CS
sir.
University.
Thank you very much for inviting me, sir. So
Yeah.
actually, this is my first faculty.
Sir, Sri Harsha sir,
development.
for accepting our invitation and clearing all the doubts about every participants. Thank you very much. Very interesting session, sir. Thank you.
Thank you very much, sir. Thank you. Thank you, sir. Thank you.
Yeah.
Actually, this is my first faculty development session, sir. So I was also a little nervous on how to, what kind of questions will there be.
Yeah, I know,
Yeah, it
because
was very engaging session, sir.
yeah, discussing with the different scientists or during the presentation with the company presentation, it is somewhat different. But I
Yeah.
know most of the faculty members actually they participated in the question and answer sessions, and
Yes, sir.
I hope this is going to help them.
Sure, sir. Sure, sir.
So thank you
Yeah.
very much.
Thank you very much, sir. Thank you.
So now we'll move ahead with our second section. So we'll start our second section in this next 1 minute. Dr. Ratnaparki, I have given you a right as a co-host. Are you there?
Yes, sir. I am.
Will you please try to share your screen? So
Yes.
we can test.
Sir, hope you can see the screen and my voice is clear.
Yes, it is clear, loud, and your presentation is also visible. So Dr. Ratnaparki will wait just for 1 minute. So at 7:30 we can start with your session.
Okay. Yeah.
Yeah. So we'll start with our today's second session. Our today's session is focusing on low power wireless technologies for future precision farming. And our today's expert is Dr. Vivek Ratnaparki. He is a staff engineer at R&D in Tejas Networks Limited, Bangalore, Karnataka, India. Before moving ahead, let me introduce you. Mr. Ratnaparki holds the PhD from Sant Gadge Baba Amrit University in the field of GaN high power amplifier design for microwave application. Has completed B and M Tech in electronics and telecom engineering. Earlier to this, he has almost 17 plus years of experience in academics and now having the 3+ years of experience in industry. Has received various research grants from AICTE India for the lab modernization and faculty development programs. Has also received Best Paper Award at the NTU University Singapore in 2018. He has done research internship at Space Application Center, ISRO, Ahmedabad. He got the project internship at Society for Applied Microwave Electromagnetic Engineering and Research that is a summit, Chennai. Has conducted more than 15 hands-on training programs for the faculty members, students, and industry persons on RF circuits and antenna design. His research area mostly focused on GaN-based broadband high-power microwave amplifiers, broadband microstrip passive active circuits and components, beamforming networks for 5G application, and presently he is working on the application like rectenna design for wireless power transfer in IoT applications. So as a communication purpose, is more focusing on the different communication technologies in the electronic circuitry. So I request Dr. Ratnaparki sir to start with this session. Sir, please.
Okay. Thank you so much, Dr. Praveen Wankhede sir, for a nice introduction. Could you please confirm one more time the screen is visible and sound is clear?
Yeah, if the screen is visible, you are audible and loud.
Okay. Thank you. Good evening to all participants. For this session, as I have been asked to talk on different wireless technologies for future precision farming. And the objective of this discussion, we will be focusing on low power wireless technologies. So as you have been attending various sessions from different eminent personalities in the field of Internet of Things, specifically for agricultural applications, this session we have been devoted for various wireless technologies which one can use to send and receive data from one point to another. To start with this discussion, to set a tone of our session, I'll devote a couple of slides on the basics of these IoTs and the market capitalization and what is being anticipated for upcoming years in the field of Internet of Things. And slowly we'll move on the topic, which is on different wireless communication technologies. So as we all know that, and we have been hearing since last couple of days, all the gadgets or devices which will be connected to each other, one device can be connected to other device or many other devices through an internet connection. That is what we use to call it as Internet of Things. As you can see on the plan of my discussion, I have categorized it into two different sections. One is the communication technology related aspects, as we can call it as some RF aspects, which will be very much needed for any system designer to consider before setting up any goals or any problem definitions. So all those aspects I'll try to cover in first half of my discussion. And once we have done with those important terminologies and aspects, we will slowly move towards the communication technologies and we'll try to categorize them not only on the basis of power, but also on the basis of ranges, because sometime we may have application which is a short range, or sometime we may have application of a longer range even. And at the end of this discussion, I would like to give a comparative analysis on all these communication technologies on the basis of their ranges as well as power. So let's start. So in IoT, as we are focusing on the agricultural applications, we can have different sensors. N number of sensors can be there, and they all will gather or collect data and send that data maybe to a cloud or with respect to end user application. And it can help to improvise the quality of agriculture, what we have been following conventionally. So that is what the use of technology in agriculture, that we used to call it as a IoT in agriculture. As I said that I just wanted to set a tone, so a couple of more slides on the topic of IoT in agriculture. Using IoT in agriculture will help to improvise the way people or farmers are doing agriculture, and it will be an effective way for the agriculture system to improvise the yield. So if you use the technology, we can, let's say, take an example of two important aspects. One is water and other is electricity. These are always challenges for farmer to manage all these resources. So using Internet of Things, if farmer can manage these resources in a well manner, so he can be on a right path to improvise the agricultural yield. So the IoT can help certainly in that regard. So this picture will let you know about the different sensors can be mounted on a simple boom and used to gather the various datas. As you have received the schedule of this program, I'll be talking more on this IoT, low power IoT networks in my other session. But just to give you a glimpse how the different sensors can be installed on a single pole, and the data can be gathered and sent to the particular node, and the action can be taken based on that. So this is how a company called as Newball, they have created this particular product, which can be very much useful for farmers. So I'll talk more on these topics in my second session, but last few slides to set the tone. We can analyze the climate conditions. Based on that, farmers can take the decision and actions can be planned. Precision farming, as I said, that example is given for water, electricity. Apart from that, let's say some nitrogen has to be spread into the farm. So that decision also can be taken with the help of Internet of Things. Smart greenhouse control all the required parameters, soil pH, moisture, temperature, all these factors can be controlled in the controlled environment which we used to call. That will be helpful for smart greenhouse. Whatever data is being collected from all these sensors can be sent to a respective cloud or a network where it can be analyzed to take the future decisions and anticipate what will happen in future. And the more important topic is agricultural drones is nowadays is a buzzword in the industry. So it can be going to benefit for farming. Okay, so this is what just I wanted to start with the topic IoT and its perspective in agricultural. Now I'll just show some of the pictures which will help us to understand the significance of Internet of Things in, let's say, since 2015 to 2025, 10 years span of a time. We are in 2024 and we are witnessing it's growing like anything. So there were only 6 billion IoT connections, as you can see here. Only 6 billion IoT connections in the year 2025. And it has been anticipated that by the end of year 2025, the number will reach to 27 billion. Similarly, you can see the revenue forecast, the number of connections, and the data generated by IoT. That would be in the range of zettabytes, that is 10 to the power 21. So huge amount of data will be transferred. And out of these connections, mostly all the connections means 45% or half of the connections will be through cellular IoT in connected cars. So this is in general total picture of a Internet of Things for the last 9 years and upcoming 1 year. From another picture which will give us an idea from global to local. As you can see here, the number market by region, if you see, for North America, it is the highest in the world. But if we focus on Asia Pacific, it is the second largest market in the world after North America. So there is a huge demand of Internet of Things in Asian subcontinent. So there is a strong urge of research and development in this particular field. As we move in our discussion, we'll try to touch on certain IoT challenges which can be addressed by research scholars. Market captured by different technologies. If you see, Zigbee is the standard communication standard which we'll be discussing. It is capturing more than 10% of the market in an IoT. Similarly, machine to machine and RFID is close to 10% or even little more than 10%. This right side bottom picture will let you know about the areas wherein IoT is being predominantly being used. For agricultural applications, the percentage wise, the details I'll share in next session, but it is almost 4%, about 4%. But mostly the consumer services will be occupying the 25% or even more than 25% of the segment of IoT applications. And these are some of the companies, top companies in the world dealing with this IoT. Okay, so with this brief, now let's go ahead. Yeah, I need not to talk anything on this picture, which is a self-explanatory. Any device, anybody, anywhere can be connected 24/7 through an internet. That is what Internet of Things. Okay, so having said that, now let me take you to the important aspect and let me discuss with you all what are the challenges are still exist with the deployment of Internet of Things related systems. So the first topic which comes to my mind is that the application of IoT in extremely difficult situations. So how it is being used? Because if you consider IoT as a system, so it will comprises different sensors, different transmitters, receivers, different microcontrollers. All they are operate, these all electronic things do operate with certain temperature limitations. So if we have certain situations, let's say very hot environment or a very cold environment, then how these sensors and electronic equipments will work, that is a still question, and it has not been solved. And if even if you pick up a particular electronic component or maybe a sensor or even a microcontroller which can work pretty well in a given environmental conditions, is its cost will be another challenging factor which has to be considered. Even in outer space, these IoT systems are not still tested, which is the major challenge as far as my understanding goes. Second important aspect, when you talk about the standardization and interoperability. So if you want to standardize the things, you should have a common protocols. If you have different sensors, different protocols are there, you should have some kind of a standardization, some guidelines, framework should be there, which is now is missing. That is another challenge of IoT. Similarly, because of that, the interoperability between different devices and system is a challenging factor. Then legal instruments is the third challenge, because if you have designed a particular IoT system, your data can be accessed by some other user. You don't have a kind of a data protection or a cyber security related aspects addressed in a low cost IoT network. So that is generally one of the issue or challenge with IoT. And some technical limitations in certain cases. Technical limitations, I mean, if you wanted to design a IoT network system, then what kind of a microcontroller, what kind of a sensor modules you have been using to your system, that will impose certain limitations in certain cases based on the conditions of geography and available infrastructure for that project, that will impose certain challenges on this design. So these IoT components generally will be based on, first aspect is identification. Then from after identification, you can see there are a number of identification technologies can be used, which we will be going to discuss. Then sensors, you can use different sensors. 10 number of sensors can be there. Depending on the parameter has to be addressed. Then the connection requirement based on the wireless technology, integration, data processing, and network. So this is how the complete flow of the different entities being involved in IoT components. I'll not go into the details on this particular picture, but when we move ahead in our discussion, I'll try to focus on the different aspects to the extent wherever possible. Okay, so as I said, I have devoted a couple of slides just to set a tone. So I did that. Now I'll start with the first part of my discussion, which is I used to call it as a physical aspects of wave propagation. Being a RF engineer, I always look to this wireless technologies as a RF perspective, not as a microcontroller or embedded engineer perspective. So whatever data I have been transferring from one point to other point, it will travel through some electromagnetic wave. So that electromagnetic wave characteristics, how it is going to propagate, whether it is going to affect on my IoT system, that has to be understood. Sometimes it may happen that you might have transferred the data, but it is not being received at the destination. Why it is happening? What is the problem? How do you troubleshoot it? So to understand or to tackle these questions, one should have, I am not saying that you have to have the detailed understanding of the RF communication, but basic parameters has to be known, because when you go and design some IoT network, these parameters are always there. I'll discuss a couple of case studies. I have planned that. Dr. Wankhede sir requested me to have some discussion on network, IoT networks, low power IoT networks rather. That time I'll be quoting a couple of parameters. So those are actually related with this EM wave concepts. So basically, to tell you, EM wave is nothing but an electromagnetic wave which travels through a space with the mode of propagation called as a transverse electromagnetic mode of propagation. We'll not go into those details, but basically it takes a signal in form of amplitude, phase, and frequency. So these three parameters are more important, but being an IoT network designer or IoT engineer, we are always interested for only one parameter, that is what amplitude. If it is in the range of my expectations, then and then only the communication will take place. I mean, the data would be transferred from one point to other point. So amplitude is the only parameter which we always take care, but the frequency is other. It is always there with any kind of a communication technology. It is well defined. As we move ahead, you will appreciate that particular aspect related to the frequency. Then there will be different types of modulations to be used based on a communication technology. That modulation and multiplexing, all these things has to be predefined, that comes with a particular wireless technology. But when it comes to the EM wave propagation, when wave is traveling from one point to other point, it will undergoes a different physical changes. When wave will incident on a particular particle, it will get scattered depending on the particle size, whether it will be going to scatter it more in forward direction or in a backward direction, more in a backward direction. That depends on the particle size on which the wave is being incident. Okay, so that is the first physical phenomena. Second is a reflection. Wave can be reflected, wave can be even absorbed. If the material is something like that, whose dielectric constant is very large and the liquid contents are more, so it will get absorbed. Similarly, it will get diffracted and attenuated also. So all these factors are there. So whenever wave is traveling, it undergoes all these physical changes. And it will happen because of we have the walls, buildings, trees. Though in IoT agricultural applications, buildings and walls will not be the major challenge, but trees and other obstacles present in the path of a EM wave, that will causes all these physical phenomena. And because of this, what will happen? The original signal will get attenuated, the signal strength will get reduced, it will get shifted in time, and even its frequency and phase will get changed. So that is how it is going to affect on the signal propagation through a channel. And for channel, for us, because it is IoT, a wireless technology, channel will be an air. So the signal will be combined because of this reflection, scattering, diffraction, will get combined at certain locations, maybe in a constructive manner. So the signal, if they are in a phase, so they will get added. So that we used to call it as a constructive interference, or it will get subtracted from each other because of a destructive interference. If the signal is being arrived at certain point and from two different reflections it has been reached and they are out of phase from each other, so they will get cancelled out each other and your user will not receive any signal. So that is what the constructive and destructive interference. And the path loss, definitely if it travels certain distance, the attenuation will be added, that we used to call it as a path loss. And definitely the Doppler shift, because all these IoT things, let's say the vehicle is moving, something is moving with respect to the transmission. So there would be change in frequency of a wave. It has been observed. That is what we used to call it as a Doppler shift. So Doppler shift, let's try to understand the BTS or some tower or maybe a wireless sensor node has been transmitted some signal at time instance t. So to reach that signal to a receiver, it will take certain time. So that will be delayed in time. t minus t0. T is the time instance when signal has been transmitted, and t0 is the time instance where signal has been received. So t minus t0 will be the time difference, initial time difference. The user is away from the source. Then if the user is moving, so that actual difference will become t minus t0 minus t1. T1 is the time instance where the user is present at current, instantaneous position of the user. So that is how the delay has been introduced in the signal reception, and this delay will cause the phase difference, and that phase difference will turn into the Doppler shift. That is what the thing which we have to understand. Maybe it is not so relevant to the agricultural applications because mostly we want it to be a stationary kind of application, but just to give you a flavor of this RF things, when it comes to the moving, the Doppler shift will causes certain imperfections. So all these waves, whatever communication technology you use, even you use Rectena or maybe any other wireless communication technology, they all uses radio frequencies which are in the range of 3 kilohertz to 300 gigahertz. 300 gigahertz, I mean 10 to the power 9. So the frequency determines behavior of wave. I mean, if you have a higher frequency, its lambda will be smaller because lambda is a C by F. So it can travel a shorter distance because as per the distance, its attenuation will get increased. Higher the frequency, its penetration ability will be also lower. But at the same time, there is advantage with use of high frequencies that the amount of data which can be transmitted from one point to from transmitter to receiver will be more in case of high frequency because the bandwidth is certain percentage of your center frequency. So different technologies, I mean Zigbee, Z-Wave, Thread, Wi-Fi, BLE, they use different frequencies, but in general, mostly they do with this ISM radio bands, which is unlicensed band, 2.4 gigahertz. Now, since these many devices are operating in the same band of frequency, 2.4 gigahertz, so there is interference possibility which can result into the degradation in performance of any system. Okay, so if you are planning for any wireless IoT network, so these are some important factors need to be considered. First, we have to have a network configuration. So environment characteristics, geographical area, all these parameters has to be considered, including the height of your nodes and receiver, the distance between them. All these things has to be analyzed first, and then you have to carry out the system level simulation basically for link budget. So I'll focus more on this link budget, why it is more important. We'll take a couple of examples on this. And once that has been done, means link is the link between transmitter and receiver. Let us say X amount of power you have been transferred from transmitter. So what is amount of power you will receive at the distance, let us say 10 meter or 50 meters or 100 meters. That analysis you should have, whether your link will work or not. That you have to do beforehand, starting your your wireless network system design. Then how much traffic would be there, what is the capacity, and optimization of entire network has to be focused. Okay. So what I was talking about these physical aspects, if you have certain transmitter, it is intended that there should be a direct path. There should be a direct path. If you can see this blue colored line, this is the direct path between transmitter and receiver. But it is never the case that the signal will take only one path, because signal will travel in a free space once it has been radiated from antenna. Depending on the radiation pattern of antenna, signal will take the shape. So it can go to this path where you can see there is obstacle, even to this path there is obstacle. Again, signal can go to this path, and there are multiple reflections. Some part of signal will be absorbed by this obstacle, some can be reflected. Similarly, from other objects also, and signal will arrive at a receiver. So received signal is having the direct path, which is the dominant one, but there are multi-path. As you can see, there are different paths which have been traversed by the signal to reach at the particular receiver. So they will have some amplitudes also. And path loss is also there, whatever amount of signal degradation has happened. So this is how any receiver will receive the signal. So this is basic flow of electromagnetic wave. Even you have a transmitting and receiving antenna. So the height of these transmitter and receivers will decide the amount of power received. So I'll talk more on this. Even you can see in the picture, climate, earth curvature, terrains, all these aspects will be heavily affecting on the signal reception at the receiver, power received at the receiver. So you have a sender and receiver. In between there is you have a link between sender and receiver, but some obstacles are present, which you can see, some walls and trees are in between. That will affect on the link budget. So that is the topic which I just wanted to focus here. Another picture is showing you the receiver is hidden in between of these two obstacles. So there is no direct path. In earlier picture, you could have seen there was a direct path, but now there is no direct path, which is actually the case wherein people are addressing. You might have seen that for this 6G applications and beyond, these reconfigurable intelligent surfaces are being used to increase the coverage and capacity, so that the user who is not having a direct link with the sender or a transmitter will also be able to receive a certain signal. That is how it is being done. Intentional reflections can be done. But in this particular picture, as you can see, there is no direct path, but signal will be coming from the particular object. And this reflection is not intended one, it is unintended one. So we have to have a link budget calculation for that based on the obstacles and the distance between sender and receiver. Okay, so coming to the electronics aspect and this network aspects, simply we have a link between sender and receiver. So what are the components present in between? There are a whole lot of components present, right from your cable, your antennas, the height of antennas, what is amount of power is being transmitted. Apart from that, you have amplifiers and these antenna gains, which are the important factors. Even their mismatch losses are also there in between. Even if you connect the cable with transmitter, the mismatch loss between cable and your transmitter will also contribute to certain amount of attenuation that has to be taken care. And all these components are pretty costly. Being a IoT engineer, we never bother about these amplifiers and antennas. Whatever module is available, let's say in a market, we try to pick it up. We don't bother about its performance parameters. And it's even if you try to buy a simple amplifier, or let's say you wanted to improvise, see, because the topic of our FDP is low power. How do we make it low power? The thing is that if the battery life is more and it is operating for a longer time, that is how we wanted to achieve it. But let's give a thought on that. If we could able to replace the battery itself, instead of 1 year of lifetime, let's say we are increasing it to the 2, 3, 4, 5 years of a lifetime, but still we are using some batteries. But if it is possible to send or to run your IoT network without any batteries, so instead of low power, can't we move towards no power? NO? Yeah, that is what the future technology will come, maybe 4 or 5 years down the line. And that is why if you have heard carefully at the introduction, Wankhede sir said that we are doing certain things related to the retina design. That is what wireless power transfer, and IoT networks can run on wireless power transfer without any batteries. Okay, so that is what it is always there to improvise the power consumption. So freeze equation or link budget is very important to consider. I will not go into the all mathematical details, which is not so relevant to the things, but I just wanted to focus on link budget. So in this link budget, there are lot of terminologies being involved. That is the reason why I have made this particular slide. So we are interested for amount of power received. We have sent X amount of power from transmitter. So what is amount of power is being received at the receiver? That is what we are interested. So that can be calculated from different parameters, EIRP, called as effective isotropic radiated power, which is a product of PT into GT. PT is the transmitted power and GT is the gain of transmitting antenna. Similarly, all these parameters are given, and now you will appreciate why I was saying that RF concepts will be not in detail, but somehow basic understanding has to be there with IoT engineer to understand these terminologies. How much do you mean by 10 dB? What is the meaning of 3 dB down? That has to be understood. Then if it is a 3 dB down, means you can understand the power is half. If you have sent some signal from transmitter to receiver and your data is showing that you are receiving a signal 10 dB down, what does it mean? Whether you are receiving actual signal or a noise, that has to be understood. Okay, so let me move ahead and talk something on the important parameter, which is a link budget. So performance of any communication link. That means the quality of communication link can be decided from the link budget, whether this link will work or not. To be honest, I have set one transmitter and other receiver, they are separated by some distance, whether I would be in a position to receive signal or not, whether it is a LTE, whether it is a LoRaWAN or any kind of a communication technology is being used. I'll quote certain examples after a couple of slides. So that is what called as a link budget. It is way of quantifying the link performance. If it is workable, then what is the performance? How effectively that link is going to work. Okay, so for that particular reason, the received power in wireless link will be mainly determined by three factors. Mainly determined. There are a whole lot of other parameters, as you can see seen on the previous slide. But these three important parameters: amount of power transmitted, the gain of transmitting antenna, and gain of receiving antenna. These parameters you can uh, uh, consider as important factors which will decide the wireless link. So if that power, means the power received minus the free space length of the link path, is greater than the received signal of the receiving radio, then a link is possible. What do I mean by this statement? I'll show you with certain examples. But whatever path loss is there and you have transmitted certain amount of power and you are expecting to receive some power, so that loss has to be minimum than the transmitted power, then only you could receive certain amount of power at the receiver. Apart from that, your minimum received signal level, which is we used to call it as a sensitivity of any particular receiver, or in sophisticated manner it is called as a link margin. So what is the minimum power which can be detected by a receiver? That has to be deciding factor in link budget. So if the difference of this link margin is positive, then only link will be possible. But again, there is one thumb rule. The link margin should be positive and it has to be at least 10 dB or more for a reliable links. What do I mean by this? I'll let you know with this particular picture. Let's say you have a link, you have a transmitter radio, you have a receiver radio. Means you have a simply, you can say, ignore about the radio. You have a transmitter and receiver. You have some sensor and you have some receiver at the user, let's say. So they will, since they wanted to transmit some signal, they cannot transmit the electrical signal directly. They have to have some sensor. This antenna is again a sensor, which, or you can call it as a even transducer also, which senses the signal basically and converts it to some another form of energy. It will senses electrical energy and convert it to an electromagnetic energy. So the antenna and transmitters will be connected through some cables. It is always there. Maybe a few centimeters of cable is there, but it is there. How do you take the power from transmitter to antenna? Similarly, it is to the receiver side, antenna will be connected to the receiver with some cables. I'll talk more on these cables. So how important the selection of cable will be there at high frequency, I'll let you know with certain example. And then there is a air channel between antenna, transmitting and receiving antenna. So just at the bottom of this block diagram, you can see on the x-axis, I have a distance, and on y-axis, there is a relative signal strength in terms of dBm, decibel milliwatt kind of a thing. So you have transmitted with some transmitter power because of the cable. Cable is a kind of a passive thing which is going to eat out some signal. So it will attenuate certain signal. So the signal strength, as you can see, dropping. Then you have an antenna. So it is not going to raise the signal strength, but the terminology EIRP, the effective isotropic radiated power will be increased. And again, when signal has been sent in the space or radiated in the space, so when it is traveling down the space, it will decays with square of the distance. And if it is a multiplicative kind of a fading and all these phenomena, so number of factors, it will going to affect on this particular signal propagation. So signal will be going to attenuate heavily in this particular region. When it reaches to an antenna at the receiver, again, it will boost up by certain amount, which is the gain of receiving antenna. The same concept, cable will eat out some power and the receiver will going to receive certain power. So you sent some X power and you have received some Y power after traveling right from all these factors. At the receiver, you received this power. So whatever power you have been received should be at least by some factor, it has to be greater than the receiver sensitivity. And the difference between receiver, what is the minimum amount of power which can be detected by a receiver and the actual power received. So the difference between that is called as link margin. And as I said on my previous slide, this link margin should be at least 10 dB or more to have a reliable wireless link. Okay. So to understand this, let's take a actual case and understand this particular concept of link budget calculation. So let us have you have a separation between transmitter and receiver is a 5 kilometers. Okay. So you have a transmitter antenna whose gain is 10 dBi. So don't get confused with these units because we are not going into the details of RF. But anyways, if you are somebody is interested for this, you can reserve your questions and we can discuss more on this. For this time, I am not going to explain all these things. Little confusing for you. Just take the numbers. So there is a 10 dBi gain and transmitting power is 20 dBm and receive sensitivity is minus 89 dBm. So these things are given and the receiver is having antenna gain of 14 dBi and the power will be 15 dBm and receive sensitivity is minus 82 dBm. So two cases are given, right? So both these cases we'll try to analyze with the picture. I'll let you know what do I exactly wanted to share with you. Remember, the cables in both systems are short, very short cables. The length of cable is not being mentioned, but the loss is given, which is a 2 dB. Right? I'll talk more on the length and how the length is going to affect how much amount of attenuation will be there with the length. So that we will discuss. And the frequency of operation is 2.4 gigahertz. So whatever I have written on the last slide, it is now depicted on this particular picture. So quickly we can understand. The transmitter is transmitting 20 dBm signal. It is being connected to the antenna with 2 dB loss cable. As I said, we don't know the length, but perhaps it is less than a meter cable or 2 meter cable because typically at 2.4 gigahertz, 1 meter longer cable can introduce the loss of 1 dB or so, even more than that. But if you have a Teflon cable or some good performance matrix cable, it can have a minimum of 1 dB of a loss for 1 meter. That is well expected at RF. Then you have antenna of 10 dBi gain. And similarly, at the receiver, you have 14 dBi gain antenna. Same cable, same distance, 2 dB loss. And here is your receiver. So the path loss, if you calculate using that equation, which I have showed before a couple of slides, 4 pi r by lambda square. So r is the distance, which is a 5 kilometers. Lambda you can calculate for 2.4 gigahertz. So you will land up with this number, which is a minus 114. You will land up with 114. Since it is a loss, we used to express it in negative sign. So this is the loss. Now the receiver sensitivity is given, which is minus 82 dBm. And we have been asked to check whether this link will work or not. So let's see this. So we have transmitted a power of 20 dBm. So this is what? 20 dBm. Antenna gain is of 10 dBi, so it will get added. We have a cable loss of 2 dB on both sides, so we'll subtract it. Then antenna at receiver, we have 14 dBi gain, and again 2 dB loss. So this is what we have calculated in electrical performances. So the total is 40 dB, but we have free space loss of 114 dB or path loss of 114 dB. So what is the amount of power we have been received? If we have transmitted 20 dBm with so and so antenna parameters and cable specifications, after certain distance of 5 kilometers, we are going to receive minus 74 dBm of a signal. So this is expected received signal at the receiver. What is the receiver sensitivity? We know that it is a minus 82 dB. So minus 82 dB, so signal is almost 8 dB above of the receiver sensitivity. So it can detect or the link can work, but what threshold we set, the at least link margin should be 10 dB, bare minimum link margin should be 10 dB. So it is not going to work effectively, right? If the signal strength is, let's say difference is very minimal, maybe 1 dB, 2 dB, or your received signal strength is lower than the receiver sensitivity, then there is a no question of link happening, right? There is no question of signal transmission and reception. But now there is a bare minimum difference between the sensitivity and received signal strength. So yeah, in a way we can say that it will work, but it can get interfered if there is certain environmental conditions, rain rate or something is going to happen, and which will attenuate the signal performance by certain ways. Okay. Or even if you change the cable some other day, if you change the cable and couple of dB more losses have been introduced into the system, then this signal communication link will not be possible to work. Now, opposite way we'll try to see. Other way, let's say 15 dBm has been transmitted. Earlier we have transmitted 20 dBm. Make a note of this because we have transmitted more power. But now we are transmitting little lesser power, right? And the same thing we are trying to work it out. 15 dBm we have sent, 2 dB cable losses, then 14 dBi of transmitting antenna. Earlier we have 10 dB of transmitting antenna, means just we are reversing the link. Earlier our transmitter antenna has 10 dBi gain. Now our transmitting antenna has 14 dBi again. Means we have interchanged the transmitter to receiver and receiver to transmitter likewise. Means antennas we have interchanged. Then receiving antenna 10 dBi again, cable is same thing. Path loss will be same because we have not changed the distance and frequency. All right, so the same picture, no need to explain it again. But now if you calculate this thing, what would be the margin this time? Because 15 dBm you have transmitted, 5 dBm lesser than earlier example. The gain is 14 dBi for transmitting, 2 dB cable loss, 10 dB gain of antenna, and 2 dB is the cable loss again. All right, so 35 dB it comes. Again, free space loss is 114. So you are going to receive minus 79 dBm at the receiver. Again, the sensitivity of the receiver is same, minus 89 dBm. So difference now it is 10 dB. So link is going to work. So what conclusion we draw? Even though we have reduced the amount of power transmission, what we have observed that the thing is that the antenna gain which we have used, earlier it was 10 dB, now it is 14 dB. So that way you can consider and understand how important these particular parameters while we designing any communication link in between. So another picture will let you know on the path loss variation with respect to the frequency. If you increase the frequency, that is why if you move on the 5G or 6G, we talk about this millimeter wave frequencies. So these millimeter wave frequencies will have lot of attenuation and they will be going to travel a very minimal distance. So the main reason is the path loss. Higher the frequency, higher will be the path loss. So that is what I just wanted to convey. Now, as I said that, I'll try to take you to this particular wireless technologies, maybe LTE, LoRaWAN, NB category 1, and NV, LTE, all these terminologies are there. And you can see in this picture, so the frequency bands for these different technologies I have listed in this particular table. So in Europe, this is the particular frequency. For North America, this is the frequency, right? So mostly 900 megahertz band is used for LTE LoRaWAN, and their channels and channel bandwidth, etc., is being quoted. Okay, so let me take you, and you can notice the link budget is 130 dB for LTE. Means any signal strength lower than this will not going to establish the LTE link. Any signal strength lower than 154 dB is not going to establish the LoRaWAN link. Similarly, you can consider for these numbers, these links will not be possible to work. Now let me take you to the actual online calculator, which you can play around maybe some other time. I'll just show you how this is going to work. So you remember the number which I have showed. I'll take the first case. Can somebody confirm that screen is coming, means the calculator is there?
Yes.
Are you
Yes, it
synchronized?
is there.
Yeah. Thank you. So first let me take you to the first link. Let us say LT link I wanted to establish. Its link budget is 130 dB. So what do I mean here is, let me have this LT kind of a link to be established, and for, let's say, the distance I wanted to cover is 100 kilometers. Should I zoom it a little bit for better visualization? Is that okay? Yeah. So let me try to analyze a LT link. Let's say it is a 100-kilometer link. For sake of simplification, I'll make the antenna gains are 0 dBis and elevations of antenna transmitting and reception at the 0-meter height only. It is not the case. They will be at some certain height, maybe half a meter, 1 or 2 meter, whatever it is. But just for sake of simplicity, let's take them. And the operational frequency, as I have shown you, let's say 900 megahertz only. Ignore REN rate and all these things, and try to compute whether LT is going to have or going to deploy a successful communication link or not. Let's click on compute. So the received signal strength is minus 131.5 dBm. So if you see from the slides which I have shown, so the number was 130 dB for LTE. And what you have been received now is minus 131 dB. So it is lower than the required link budget. So this link will not work, means LTE will not work for 100 kilometers, right? That is what we could conclude from this case. So what we have to do? So we should reduce the distance. Let me reduce it to 90 kilometers. Let me check whether it will work. Now it is minus 130.6. So it is still below the required value of 130. Again, I need to reduce the distance. That is the only solution, because I could not introduce the amplifiers in between, or I could not replace the cables. I could not do any other electronics options to improvise the link performance apart from reducing the distance. So let's say 80 kilometers now. So for 80 kilometers, you could see the number is below 130. And then you can say that the link will work now. Don't confuse this number with the link margin. The link margin is something different, which I was trying to tell you in aspect of the link establishment. Link budget is something different. For LTE, the budget number is 130. So the received signal should be more than that value. That is why we are trying to get the number below 130. So what is the conclusion? So LTE can work up to 80 kilometers. And again, the note is that we have not considered any atmospheric impairments. We have not considered any cable losses, and we have not considered any practical scenarios present in this particular environment. So this number varies with different path loss models. I'll show you what do I mean by path loss models. So this is what I just have calculated for LTE. What is the maximum range? 80 kilometers in certain hypothetical assumptions. Similarly, for LoRaWAN, the number is 154. That indicates the LoRaWAN, the name itself indicates long range wide area network. So it can work for a longer range than LTE. So let me try to consider this also. So can LoRaWAN work for 1000 kilometers? Okay, let's compute. So number should be lower than that. So minus 151. Yeah, the number is what? 154 dB. Yeah, it can satisfactorily work. Let me increase the number because it is minus 154. So let me make it 1300 or something. So still the number is below the required one, means higher the value of our required minimum number, right? It is in minus. So it can work up to 1300 kilometers. If I make it 1400, whether it will work. So let's compute. So it will not work. The number is lower than the required link budget. So the LoRaWAN can work up to 1300 kilometers. This is what we used to call it as a link budget analysis. Let us try to consider you have been inserted some cable whose loss is 8 dB. If you consider a cable which I have shown you on previous slides, the cable connecting from transmitter to transmitting antenna and receiving antenna to the receiver. So that cable, somehow it is introducing some attenuation of 8 dB. Only for one site we have been considered. How long the cable would be? Typically 5-6 meter cable may be there. So it is being considered 8 dB loss is there. So compute the signal. Now it is very less signal compared to our required signal of 154 dB. So this link will not work. Just you have considered the 8 dB cable. Now the distance, only option with you have to reduce the distance. Let us make it back 1000 kilometers. Still, it is 159. We are interested to have this particular budget, 154 dB. So still this link will not work even for 1000 kilometers. So let me make it directly 500 kilometers and check it out. So now it is below 154, means higher the value from our required number. So this link will work. So from this case study, what we can understand is even the cable of 8 dB attenuation. So typically let us consider 1 meter cable will attenuate by 1 dB. So 8 meter cable will attenuate the signal and will reduce the distance, communication distance from 1300 to 500. That means 8 dB cable is actually going to eat up 800 meters of a, 800 kilometers of a distance. Means 8 dB attenuation or 8 meter cable will be 800 kilometers in air. So that is why the dB is more important term and which can give you an idea about the link budget analysis. Similarly, you can carry out the link budget and understand what is the maximum range. That is why people used to say, I have established the LoRaWAN, but it is not working beyond 50 kilometers or 10 kilometers. So what is the reason? So this is what the reason. Different aspects has to be considered. Okay. So this is what we have covered, the first part of our discussion. If you have any questions related to this part, I'll take a break of a moment so that you can get some breathing time and be ready for the technologies which we are going to discuss. Okay, let me continue with this second half of my discussion. All right, so we are on time. Now we'll discuss on these wireless technologies, networks, topologies, and standards. So quickly, I'll introduce you what are the technologies I'll try to touch upon. Zigbee, Bluetooth, Wi-Fi, Thread, LoRaWAN, Z-Wave, then some cellular technologies like GSM, NB-IoT, and Ocean. All these technologies we use for IoT networks. So we have different networks, LAN, WAN, MAN, depending on the distance we wanted to cover. So all these wireless networks have been categorized and different technologies are being used for different wireless networks. So let me move quickly. So based on these applications, we use the different wireless networks and different wireless standards with their data rate and frequency, latency, everything is being introduced, and the IEEE standard is given, and the distance up to which they can connect the link. So WiMAX is the maximum thing which you can see. The higher the distance, more than a kilometer can be covered by wireless interoperability microwave access. Then below that we have a Wi-Fi. Now this 30-50 meter distance can be increased by many folds if you use the Wi-Fi halo. I will touch on that particular technology of Wi-Fi, which works on a low power, which is the interest of our course. Okay. So these are different topologies. I don't discuss much on this. We know the star, mesh, and different topologies, ring topologies we used for network. So quickly I'll go to this. The crux of this slide is that for low transmit power and shorter links, we go for the mesh kind of a topology, which allows a fairly long battery life. So typically the Zigbee, Z-Wave, and Thread, they do use a mesh kind of a wireless technology. We have a star kind of a topology, which is used for low power wide area networks. So this kind of a thing is used in Wi-Fi and cellular networks. They use this star topology. So we have point-to-point kind of applications. It is much simpler than mesh or star, and which is not very useful in IoT because it transmits the data unidirectionally most of the time. So this is not too useful because in IoT kind of application, we have multiple sensors. So point-to-point is not expected. Point to multi-point kind of application is always expected in IoT kind of applications. So these are the different wireless standards. For Wi-Fi, we have 802.11 WLAN standard. For PAN networks, we have .15. For microwave access, we have .16. Different standards are there. So these are governed by IEEE. So the communication network, because whatever communication IoT network will be there, it should be a low cost. So the cost parameter will be at the top, otherwise it will not help to the mass public. Then power consumption will be minimum. I will take certain case studies on low power in next session. So then long battery duration, these are two interrelated terms, low power and longer battery duration. If the power consumption is low, the battery can withstand for a longer duration. So high number of connections should be addressed by IoT network. Different bitrate requirement should be there. The range has to be as maximum as possible. Processing capacity should be low. Storage capacity should be low. All these are the requirements from any IoT communication. And the network architecture and protocol should be as simple as possible. So these are certain application requirements. You should have the varying bandwidth requirement, long range versus short range. This is what the application may be, a short range application or a long range application. Then battery life as long as possible, as I said, has to be required, expected, and various quality of service parameters. What do I mean by QoS parameters is the related to throughput, latency, and bandwidth. So latency should be as minimum as possible, and throughput should be as maximum as possible, close to the bandwidth of the given channel. Okay, this is what I have considered and discussed on. So this topic is related to the different models. So quickly I'll go to this. There are 4 different models: device to device, device to cloud, device to gateway, and backend data sharing. So all these 4 models are there. So most commonly, Bluetooth, Z-Wave, and Zigbee are the device to device kind of communications. So they transfer information or data from one device to other device. So this is the pictorial representation of device to device communication. Let's say you have a light bulb from manufacturer A and you have a switch from manufacturer B. So they have been connected through this particular standard and it is called as a device to device communication. Similarly, you have a device to cloud communication. So certain protocols are there in between HTTP, TLS, TCP, IP. These are the protocols being used to connect through the cloud. These 2 devices will get connected. Temperature sensor and monoxide sensor have been connected through a cloud. So this is a device to cloud kind of a communication. Then we have a device to gateway communication. So personal fitness trackers and all these things are the example of device to gateway communication. So this picture will let you know about, let's say, Bluetooth Smart IEEE 802.11, which is a Wi-Fi or long range WPAN are the examples of this kind of device to gateway connections. So these protocol stacks are being used. Again, it is being connected. This is the same thing, temperature sensor and monoxide sensor connected through a gateway. And the final one is back-end data sharing. So if you have a light sensor and you have been sharing the data to different application service providers, so it is being done in this particular fashion. You have protocol stacks, COAP constrained application protocol or HTTP protocol. They will be connected to the service provider 1, 2, and 3. So this is the example of back-end data sharing. All right. So let me start with this communication technologies in the fashion where they have been categorized in long range, medium range, and short range. So for long range applications, you can see cellular networks, LPW, LoRaWAN, Sigfox, all these are used for longer range. Medium range, popular technologies are Zigbee, Thread, Z-Wave, and all these Wi-Fi, Hello, Li-Fi, etc. Then short range, for short range personal applications, Bluetooth low energy are being mostly used, and RFID is also used for short range. But to focus on the power consumption, so this picture will help us to understand the range and power consumption with data rate. If you consider the personal area networks such as Bluetooth or BLE, they consume very low power, but they are well suited for shorter range applications only. If you have a long range, low power application, so Sigfox, Telensa, LoRaWAN, all these things are very much popular, and LoRaWAN, that is why it is very popular. Even NB-IoT is used in this. I'll show on the next picture. But if you don't have a constraint of power consumption and wanted to send the higher and higher data, then these Wi-Fi, WLAN technologies or cellular technologies will be most suitable. So this picture will let you know about this NB-IoT, LTE, LoRaWAN, their data rate, power consumption, and range in real number. Earlier slide, I have just shown you a general picture which talks about this ranges, data, power consumption, and ranges. But now the real number, if you want, the link has to be established more than 1 kilometer or so. So the LoRaWAN would be the most appropriate choice. But it is again low data rate and lowest power consumption. That is why it is more popular in agricultural applications, wherein we don't have a huge amount of data has to be transferred. I am not saying that always it is very less amount of data, but instantaneous data transfer is very bare minimum in case of agricultural applications. Okay, so short range technologies quickly will touch on the Bluetooth, NFC, and RFID. All these are generally used for short range technologies. Why I'm saying generally used? Because nowadays, Bluetooth upcoming modules can be used up to certain tens of meters. I'll take you to that particular slide and talk more on the Bluetooth. So different short range technologies, as you can see from the picture, they are being shown. So out of that, Bluetooth is more popular. So these are the features of Bluetooth. So Bluetooth 5 is there. It has the 5 times the range of the earlier Bluetooth. Yeah, it works on 2.4 gigahertz of ISM band. See, the class 1, we have 3 categories, 1, 2, 3. So the maximum power consumption is 100 milliwatt, which if you convert into dBm, it comes around 20 dBm. So its range is 100 meters. That is what I was trying to tell you. Even Bluetooth can be used for few tens of meters. So the category 2 is lower power, you can say medium, and the lowest is the category 3, which can goes up to 1 meter only. Okay, so I'll take you to the actual, the way I have done for, link budget calculation. Let us take a case of Bluetooth range estimation. If you have been using Bluetooth module in your project and you wanted to understand what is the reliable link can be established by using the Bluetooth. So let me take some receiver sensitivity, which we have discussed earlier. Now we have different path loss models. That is what I was talking some time before. If you have different environmental conditions, let's say outdoor, industrial, office, or home. So mostly agricultural applications will lie in this particular domain, which is outdoor, but certain agricultural applications may be considered home applications or even industrial also. So let us consider your transmit power is 0 dBm, transmitter antenna gain is 0 dBi, and receiver antenna gain is 0 dBi. So for outdoor applications, Bluetooth can work up to 55 to 78 meters, right? If you change the scenario, if you change the path loss, let's make it industrial. So can somebody think on this? If you could answer this, I'll be more than happy at the end of session. I'll not going to answer this why the range has been reduced. For outdoor, it is 55 minimum, and for industrial, it has been reduced to 32. So what may be the reason? Because we have discussed something related to the RF aspects. Based on that, you can think on the same line. If you come to the office, even distance has been reduced, now 15. Now home, you can see it is close to 26. So based on the path losses, the distance traveled by a same Bluetooth module can be changed. If you change the sensitivity also, the number will also change. If you have the highest sensitivity device, distance can be more. See, even 90 meters you can go in outdoor conditions, right? So that is what minimum 90, maximum 125 meters can. These are the all ideal cases. And if you want to see what are the different models being considered, you can simply click on this and see assumptions, what this wonderful site has given. So a lot of physical aspects are covered for this particular thing. I hope you will appreciate what topics we have discussed at the start of this session. Link margin, transmit antenna height, receive antenna height. These three important parameters they have considered for 4 different path loss models. Outdoor, industrial, home and office. Right? Even for home and office, they have considered the same thing. So this is how this physical aspects will be useful to calculate our actual range of any particular application. So this is what I just wanted to show you related to Bluetooth. Let me go to the next near field communication, which is the short range radio communication standard. It has been first consumer trial done in the UK year 2007, and it is mostly suitable for 10 centimeter or even less. So frequency, it is being not 2.4, it is a 13.56 megahertz, and the data rate is in this particular range. And the applications where NFC is used are listed: smart wallets, action tags, and access controls. So let me compare this thing, Bluetooth, BLE, NFC, and RFID on a single slide. So I was telling you related to this RF physical aspects. That time I said that modulation is the important parameter to be considered for particular technology. So as you can see, based on the different technologies, different modulations are being used. Sometimes the same modulation scheme being used for 2 wireless standards, but it is defined in the particular technology protocol. So wireless standards, the frequency bands they have been used, data rate, maximum data rate they can support. So maximum NFC can support 424 kbps, but if you consider the Bluetooth, it can support up to 123 Mbps. So bandwidth of the particular channels and how many number of channels are there. Range, now you know better. You can debate on that why the 10 meter is written because I have already shown you the Bluetooth range estimator. So it depends on the lot many factors, but typically it is being assumed it is going to support bare minimum 10 meter of a distance, even if you consider home or office environment. Topology and encryptions are being listed for different wireless technologies. After short range, we have a medium range wherein Zigbee, Thread, Z-Wave, Wi-Fi, and Li-Fi is there. For the Li-Fi, the signal will be signal carrying capacity and distance will be increased like anything. I'll come to that point little later. So Zigbee, it is a quite popular in home automation kind of a thing. So it uses 2.4 gigahertz only. Its power usage is higher than Bluetooth, but less than Wi-Fi. So it is a better than Bluetooth, means in terms of ranges, but less than distance, lesser distance will be covered as compared to Wi-Fi. Similarly, we have a Zigbee Pro and Zigbee IP. These are the stack profiles of Zigbee. So Zigbee Pro is actually optimized for larger networks, but it is more expensive and requires more memory if you consider the ZigBee Pro. So ZigBee Pro can easily support networks of thousands of wireless devices, which ZigBee generally the original ZigBee was used to support only hundreds of devices. So ZigBee IP provides IP connectivity for ZigBee devices. So this is what the three standards are quite popular in ZigBee. Then we have a thread. So it also uses the same frequency band, ISM, unlicensed band. Its range is 100 meters. Data rate is quite low, which is a 250 kbps. Z-Wave is using a 900 megahertz. Range is 30 meters. The data rate is quite low again, 9.6 or 40 or 100 kbps, depending on the version of the Z-Wave which we have been using. And lamp controllers and sensors are some of the applications where Z-Wave can be used. Then the another popular wireless standard is Wi-Fi. So there are different standard of this Wi-Fi, as you can see, 802.11 A, B, G, N, AH. So this is Wi-Fi hollow. I'll come to this maybe on next slide. So the frequency bands are different. For first standard, it was 5 gigahertz. So throughput was almost 54 Mbps. But for this 11N, the throughput, you can see the maximum throughput is there and range is also highest. And it can operate in 2.4 and 5 gigahertz. So some of the disadvantages of Wi-Fi, because being a power consumption, Wi-Fi consumes the higher power compared to other wireless standards such as ZigBee, BLE, and Z-Wave. Wi-Fi is not capable of meshing. That's why the connectivity is limited by access point coverage. So Wi-Fi direct or Wi-Fi point-to-point was recently developed to overcome these disadvantages. And this is what I was talking about Wi-Fi Hello. So it is 802.11 AH specification, operates in 900 megahertz band, and it can cover the distance up to 1 kilometer. Okay, and the thing is that even it can consume a lower power. So it can compete with the Bluetooth and other technologies for longer range kind of a thing. So this can operate, now you can see the Wi-Fi Hello is operating in 900 megahertz of a band, and other standards are in some other particular frequency bands. So this is quite popular nowadays. So let's compare these medium range technologies based on their modulation, standards, frequency bands, whatever the maximum data rate they are. The number which I just want to take your focus is Li-Fi. So basically, Li-Fi is implemented in Gujarat. Some of the villages, they are the first village in India to use the transmit the signal over light fidelity. As we have wireless fidelity, we have a light fidelity. So the signal being transferred on light, hence the band is very high. You can see terahertz. Because of higher frequencies used, the data transmission capacity or data rate, you can say, is very high, more than 1 Gbps. So the bandwidths and ranges are being noted here for the medium range technologies. So quickly, let us go ahead on the long range technologies. So we have NB-IoT, LoRaWAN, Sigfox, LTE-M, and 5G. These are the wireless technologies which you use for long range communication. So 4C approach is generally used for low power wide area network kind of a technology. First C is capacity. What is amount of data or speed it can be catered? That is what capacity stands for, whether it is a uni or bidirectional kind of a communication. So that technology has to be considered on this particular first C. Second C is coverage. What is the area, outer coverage area, indoor cover? Now you better understand the coverage area will be based on the different physical aspects. Outdoor range would be different, indoor range would be different, underground will be different. So this coverage is the another C. Third is the cost per device, and the scalability, how you can improvise your network system. That is what cost scalability is there, and how much amount of power consumption is there with this particular low power band technology. So it's energy, if the device is more efficient, it will be its battery will last for a longer time. So that is what the power consumption. And what is latency? So all these terms catered by consumption. So this is the 4C approach related to any low power band technology we have to consider. So there are different low power band technologies. Sigfox LoRa is the most popular one. IGNO has come up with this RPMA. So I have shared this on before some of the slides I shared on this RPMA. I hope you have noticed this. Let me go back. Yeah, here I have shown you all these technologies I shown. This is the manufacturer of this particular technology, and this is random phase multiple access kind of a modulation technique they use. So it can be used for very long range of communications. Hence, it comes under the long range kind of a wireless technology. So LoRaWAN, basically it uses a CSS kind of a spectrum modulation technique. Its sensitivity is pretty high, up to -137 dBm, or even it can be increased to -142. Now you see LoRaWAN, we have already done certain calculation for 1000 kilometer, 500 kilometer, but realistic scenario, it comes into few tens of meters considering all the physical aspects. So maximum 15-20 kilometer it can support. So strong indoor penetration is there because the frequency use, it is 900 megahertz, and range can be 2 to 5 kilometer in dense urban and 15 kilometer in suburban. Dense urban, I mean, there are a lot of obstacles, so it will affect on the signal range. So Sigfox is another thing which can compete with the low power LoRaWAN kind of a technology to increase the distance. So it is there for higher power, higher distance coverage. NB-IoT is quite popular nowadays. Jio has started this NB-IoT, and it is being used in India for this long range communication. So it works on 700, 800 and 9 different bands of frequencies depending on the GSM, as we have different bands for LTE, and range can be at least 10 to 15 kilometers. Typically depends on the cell site. So little bit information on NB-IoT, because this is quite popular kind of a wireless technology for low power, wide or longer distance coverage. So it is a secure and reliable since it is using a GSM kind of a thing. So encryption and this data security is always there. Its battery life is longer compared to other wireless technologies for low power and wide network. So it has already integrated with the cellular system. So the deployment and its scalability is quite simple, and a deep penetration because it is being said that it is used as cellular coverage. So it can penetrate to the longer distances, even indoors and underground. And the most important aspect of NB-IoT, why it is becoming so popular, so it can connect billions of cells or billions of nodes. That is why NB-IoT has become so popular. So these are some of the examples, and you will be more than happy to see agriculture is one of the application of NB-IoT. Right. So let me go to the next slide where we compared LoRaWAN, Sigfox Ingenu and NB-IoT. So this is the data rate. If you see for NB-IoT, data rate is little higher if you compare with any other. Just Sigfox has little higher data rate in downlink, but if you compare this even in downlink and uplink, NB-IoT basically is using the cellular kind of network, so having higher kind of data rate. So finally, I'll just touch on this GSM. This has different standard GSM, GPRS, 2G, 3G, 4G, 5G, 6G, whatnot. So it is coming in soon. We'll use the 5G for IoT applications also. So different frequencies based on all these cellular generations. So range can be 35 kilometers or even more if you use the HSPA kind of applications, and data rate is quite good if you use the LTE or 4G, 5G applications. So this is what we have been using GSM in different examples. So let's compare all these long range, low power wireless technologies on the basis of scalability, range, coverage. So let me take, let's say Sigfox is there. So it is going to provide the longer range. But at the same time, if you see the scalability of Sigfox is a little lower, right? Battery life, if you see for Sigfox only, the highest the battery life, its range is more, coverage is more. So that is why Sigfox is the winning candidate, we can say. If you consider LoRa, so its range is lower, but battery life, cost efficiency, and deployment is better than that of Sigfox. For NB-IoT, the latency performance is the highest one, payload length and quality of service. If you compared with any other long range, wide area network, low power technologies, NB-IoT outperforms in these particular parameters right? But the battery life for this NB IoT is little poor. Deployment and cost is also poor in comparison to that other technologies. So the same picture with 3G, 4G, 5G kind of wireless technologies. And if you consider Zigbee and low power WAN, so based on these different parameters, geographical coverage, range, power consumption, bandwidth, all these technologies can be covered. And based on our application, what is the range and power consumption we are expecting from our IoT network, we have to pick up a particular wireless technology. So I'll take a couple of examples during my next session to do some case study and analyze how to do the low power wireless IoT network design, that we will touch on these aspects little bit: power consumption and range. Range we have covered in some manner in terms of link budget and all these different wireless technologies. Power consumption related more examples will cover in other session. So that is what I was actually expected. I am little fast during my latter half of my discussion, but I have set the tone and I have given some of the important aspects which can be easily useful and applied to once we have started the analysis of these wireless technologies. So thank you from my side. Over to Coordinator Dr. Wankhede, sir.
Thank you, sir. We'll take one or two questions. Okay.
Yeah, please.
Yeah. Dear participants, if you have any questions, either you can put them in a chat box or you can unmute yourself and ask the questions.
Sir, good evening, sir.
Yeah, good evening, please.
Sir, this is regarding if we want to set up a LoRaWAN for crop yield predictions.
Mhm.
So what could be the procedure like to get the soil parameters?
Procedure,
For
do you mean? Yeah, got
Yeah.
your point. Procedure, do you mean to have an entire system you are asking about?
Sir, actually, I surveyed this.
Mhm.
So the we had set up, we had put a proposal, GST proposal also,
Mhm.
for setting up a LoRaWAN setup for getting the real-time data
Right.
and making the applying deep learning algorithms for
Okay.
crop yield predictions.
Right.
So what could be the is it feasible, like the budget or whatever?
No, I got your point, but what actually you are expecting?
Sir, is it possible for one individual to bear the cost of setting up this and deploying the network and getting the details and all data?
Yeah. Yes. See, there are too many factors to be considered when you are trying to deploy any IoT network.
Yes, sir.
As I said that I will consider all these factors, IoT elements. When
Yes,
you
sir.
are considering IoT, right from sensors, what you will be using, to the microcontroller, what are
Mm.
the communication protocols you have been using, what is the
Yes, sir.
distance you have been targeting, all these
Mm.
factors has to be considered. And they will be deciding factor for cost of this thing.
Okay, sir.
Yeah, but it can be bearable. Generally, these IoT networks are not so costly.
Okay, sir.
Yeah.
Because I wanted to take the real-time data as well as the historic data
Okay.
of a particular region. I want to do it region specific, like 1 kilometer, 1 acre
Yeah,
of a land.
Right. That can be very much doable.
Huh.
You stay tuned for my next session, wherein I'll be discussing some real case studies where I'll give you the sensors, microcontrollers, and actual scenario wherein the data has been captured and sent to the particular point, which is what
Okay,
you
sir.
are actually looking for. So
Yes, sir.
entire analysis I'll try to do right from the IoT elements to the network.
Sure, sir. Thank you, sir.
Yeah, thank you.
Good evening, sir.
Yeah, good evening.
Sir, I want to ask very basic question as I am teaching this subject cellular network.
Okay.
I have to take practicals based on these link budget analysis calculations. Like you have changed the transmitting power, you have changed the antenna height, transmitting distance, and all that. So whether these softwares are easily available to us?
Yeah. See, I have not taken it to the very deep level of this analysis. I have directly taken you to online calculators.
Yeah, we can access those
Yeah,
calculators.
you can access. I have shared the link on my PPTs only.
Okay,
You can
fine,
go
sir.
to those calculators, and what suggestion I have from my side, you can have a detailed Excel calculator can be built from your side, or even you can write a
Yes.
simple code in MATLAB based on the
Okay, sir.
mathematical equations.
Right, right.
The
Yes.
path loss can be calculated from two formulas. One is a freeze transmission formula, which I have shown.
Okay, sir.
TGR upon 4 pi r by
Yes,
lambda square.
yes,
That is the freeze
yes.
transmission formula. Second, you can
Okay.
use a radar range equation.
Okay.
Based on this, you can have, let us say, one experiment, you are calculating a path loss by two different
Okay.
methods. One
Okay.
is a freeze transmission, other one is
Yes.
radar range equation. Then second
Okay.
experiment, you can plan something like that. You have different environments. Means
Yes.
the something which I have showed related to Bluetooth range estimator. So different
Yes.
path loss models you can consider. And
Okay.
let us say outdoor path loss model, indoor, home office, something like that. And
Yes.
different path loss models
Yes.
will give you different ranges.
Yes, sir.
So that is what you can plan, and everything can be very comfortably done in MATLAB or maybe some open source tool like Python. You can put
Okay,
the
sir.
equations and calculate it. Yeah.
Yes. Thank you very much, sir.
Thank you, ma'am. Thank you.
Okay, is there any further question? Okay, so thank you all the participants. Thank you, sir, for enlightening all the types of different communication technologies that are generally used in communications. So as you rightly pointed out that maybe tomorrow we'll cover some
Yeah,
of
system
the
level things I'll try to touch on.
so the networks that maybe possibly will use for the farming purpose that will look in tomorrow's session.
Okay.
So if we do not have any questions from the participants, we'll end the today's session.
Okay. Thank you.
Yeah, thank you, sir. Dear participant, I have shared the feedback link in the our chat box. So thank you all the participants. Please complete the feedback submission. Tomorrow we'll meet again at 6 p.m. We have two sessions tomorrow. One will be the low power IoT networks that we can implement for any different farming applications by again Dr. Vedratna Parki. And then at 7:30 p.m. we'll have a session by Dr. Papu Yadav. He is the assistant professor of the precision agriculture AI engineering at AGN Biosystems Engineering, South Dakota State University, USA. He is going to discuss some of the revolutionizing agriculture with cutting edge technologies. So we'll meet tomorrow at 6 p.m. again. So thank you all. Good night.